Hello my dear students, welcome to Deeksha Karnataka. Sorry for slight delay. There was some technical issue from our end. Just a second. Sorry for slight delay. There was some technical issue from our end. Just a second. Sorry for slight delay. There was some technical issue from our end. Just a second. I hope everything is okay now. So if you can hear me, please let me know. Yeah. Hello Gia, hello Blossoming Flower, Flora, Parth, and Jinri, Samarth, Mehendi, Dharani, Kiran Kumar. Okay, so I hope that issue is resolved. If you can hear me, please let me know. Okay, now if you are not able to hear me, also let me know. If you can hear me, also let me know. Okay, thank you. Good morning Asiya. Okay, so today what we are going to do, as I have if you have seen my one marker video, there I have discussed 105 very important MCQs. Today we will start with MCQs and then we will move into numericals and derivations, the few things that where you lose marks. I will discuss that as well. So this will around 2 to 3 hours lecture. So have your breakfast and sit with your coffee or tea, whatever you like, so that you don't miss out on anything. Okay, so we will start. Obviously warm-up exercise is our MCQs. So you will start try to close the MCQs as soon as possible, and then we will go into the numerical part. And also I will give you suggestions on which are all the important chapters you should study for numericals as well. Okay, so let's start. Dipole moment is a vector quantity which is pointing from minus q to plus q along the axis of the dipole, plus q to minus q along the axis of the dipole, infinity to minus q, plus q to infinity. Okay, so what is the answer? Yes, Samarth. We will practice more MCQs, and remember that you do not need to practice too difficult MCQs. Okay, that's why I have decided I will give you the MCQs which are actually on level. There will be 1 or 2 MCQs which will be medium, not too difficult. Maybe you need to think a little, then you have to calculate or do too much of calculations. Okay, so those are called HOTS MCQs. There will be 2 HOTS MCQs. For do not worry about HOTS MCQs. They will be maybe match the following kind of question, or statement 1, statement 2 based questions, or small numerical question. Okay, very small numerical. They will just give you the value. You just need to put that values into the equation and calculate it. So that will not be very difficult. Okay, so don't worry too much about HOTS. I know there is a tendency of students we are struggling in HOTS. There will be 2 HOTS MCQs, and those 2 HOTS MCQs will not be that much different. Okay, last year there was one AC question came that was based on a diagram. So that kind of questions might be coming, but you should be able to figure them out if you practice enough MCQs. And do not practice too difficult MCQs. Too difficult MCQs will be there for a KCET, but not for your board exams. Okay, so question is an example question of your board level MCQs. Very easy question. So dipole moment is a vector from minus q to plus q, right? So dipole moment always direct from minus to plus, and it is along the axis joining the 2 charges. So correct answer is option A. Now let's move on to question number 2. The electric potential due to a negative point charge at a distance small r is. So we have seen potential due to a single charge, electric field due to a infinite line charge, electric field due to a plane sheet which is constant by the way, and electric potential due to a point charge, electric potential inside a spherical shell. So these are the common cases. Okay, So here first thing that you have to identify is that potential. They are not asking about electric field but potential. Field and potential are like cousin brothers, so you might be confused a little. So because both of them are almost have the same coming from same concepts, right? So electric potential due to a negative point charge. The charge is negative, so electric potential will also be negative. Electric potential is a scalar quantity, so it will be negative, and electric potential due to a point charge, you have done the derivation. Electric potential due to a point charge varies as 1 upon r, right? And because it's a negative charge, it will be negative as well. So potential is negative and varies as 1 upon r. Okay, clear? Now let's move on to the next question. The following are statements related to self-inductance. The self-inductance of a coil depends on geometry and the permeability of the medium inside it. The self-inductance is a measure of electrical inertia and opposes the change in current through the coil. So this is a Horst question. So whenever you see there are two statements, two statement based question or one assertion reason based question, they are considered to be Horst question. Okay, so let's understand. Both statements are wrong, only statement 1 is correct. Both statements are correct, only statement 2 is correct. So here you have to identify whether both statements are correct or only one of them is correct. Yes, 2D is correct. So blossoming flora is saying 3C, Nagraj is saying C. So self-inductance of a coil depends on its geometry and on the permeability of the medium. Self-inductance, if you remember, self-inductance is proportional to its area, square of the number of turns per unit length and the length. Okay, so this is the main thing that on which it depends. Also, it depends on mu naught. Okay, mu naught is the permeability of the between the coil. Okay, so if you put air inside, then it is mu naught. If you put something else, then it will be mu associated with this metal. Okay, the self-inductance is a measure of electrical inertia. Inertia means which tries to stop the current that is being flowing through it. Okay, opposes the change in current to the coil. This is the Lenz's law. So this is also correct. So both statements are correct. So we will say both statements are correct. Now question number 4. A ray of light is incident on glass air interface at an angle greater than the critical angle for the pair of the media. Then the ray undergoes. So ray of light is moving from glass to air. So suppose this is glass, this is air, and it is moving from glass to air. An angle of incidence I is greater than critical angle. Okay, then what will happen? It will go through refraction only, partial reflection and partial refraction, total internal reflection, grazes the surface at the interface of the two media. Obviously easy question. Yes, Nagraj, option C is correct, right? Samarth is also correct. How much MCQs are there? 30 MCQs, Aisa. 30 MCQs, 30 more MCQs. Okay, MCQs are the portions where you lose marks, so you have to build your confidence by practicing more and more MCQs. Okay, now here, because I am discussing about MCQs, if the same question is asked and they said that the angle is exactly equals to critical angle, then total internal reflection will not be correct. It will be grazes the surface at the interface of the two media. So same MCQ can be asked different ways. So even if you practice 105, 100, 200, 300 MCQs, if you don't able to identify the variations, small subtle variations in them, then entire practice will be not effective. So you have to identify, okay, this is the concept. So if you understand the concept behind the question, then any variation of this same question you will be able to understand. I will always request you, don't try to memorize each and every MCQs, but try to understand the concept behind the MCQs so that you will be able to answer those questions. Now another Horst question, statement 1 and statement 2 based question. Resistivity of metals increases with increase in temperature. Okay, increasing the temperature of metals causes more frequent collision of electrons. Both 1 and 2 are true, and 2 is the correct explanation of 1. Both 1 and 2 are true, but 2 is not correct explanation of 1. 1 is true but 2 is false. Both 1 and 2 are false. So which of them is correct? So resistivity of metals increases with increase in temperature. So resistivity is proportional to temperature, and second statement says that increasing the temperature of metals causes more frequent collision of the electrons. So you can answer this in two ways. Okay, I will explain both. One is very theoretical, easy. Yes, Aisha, Dharani, Samarth, Blossoming Flora, Nagaraj, everyone is correct. Both are true. Now why both are true, you have to understand this. There are two reasons. First of all, more electrons are vibrating means it is basically producing more resistance to any electron which is trying to drift. Okay, if you apply electric field, the electrons will be drifting, but because there are more vibration in the electron will drift slowly, and drifting slowly means the resistivity increases, because resistivity is the only thing that depends on temperature, and consequently resistance will also increase. Now one more thing that you have to remember, that resistivity is inversely proportional to the relaxation time. Okay, so higher the relaxation time, resistivity is directly proportional to relaxation time. Conductivity is inversely proportional. Resistivity is directly proportional to resistivity is inversely proportional to relaxation time. Okay, so here what happens, as you are increasing the temperature, the electrons are vibrating more, so the collision between electrons are more. That means relaxation time decreases. So decrease in relaxation time means increase in resistivity. That is also a point. Okay, relaxation time, in terms of relaxation time also you can explain that because relaxation time decreases, because electrons are colliding more frequently, so relaxation time decreases, so resistivity has to increase. Okay, this is one more point that you have to remember. This is another concept behind the same question. Okay, that's why it is considered to be a HOTS question. Now before I continue, just wanted to tell you that those who are preparing for your KCET exam, KC30, the 30-day crash course batch, live batch is available for purchase. The class will start from 21st of March, that is after your PU2 exams are over, and it is currently available at a price of 2499, and this is a special price. Price is valid only till 25th of February. The prices will go up after 25th of February. Okay, and what are all the offerings in this course? You will get live online classes, you will get KCET previous year questions with solutions in video lectures, complete syllabus revision of PU1 and PU2. Okay, you will get chapter wise KCET PYQs in a test format, which is very unique to our course, 10 full length KCET level paper. So if you are preparing for KCET, then definitely this will be very, very helpful for all of you. Okay, now let's move on with our lecture. The Lorentz force is the force on a charged particle, and if you want to purchase or if you want to register yourself, the link is given in the description section of this video. You can go and click that out. You will get the access of the course. The Lorentz force is the force on a charged particle moving in a region containing only electric field, only magnetic field, both electric and magnetic field, only crossed electric and magnetic field. Crossed means if electric field is in this direction, magnetic field will be in this direction. This is called crossed. Okay, so this is called crossed electric field. Now which of them is correct? Sixi, yes. Srushti, Samarth, Aisha, Blossoming Flora, distortion. Okay, Sriraksha, everyone is correct. Option C, both electric and magnetic field. There is no such cross electric field and cross fields are not required. Even if they are parallel, Lorentz force will be there. Okay, now another HOTS question. So now column 1 and column 2 match the following. So you have to match it. Self-induced EMF, EMF induced in a rod moving in a magnetic field, AC generator, transformer. On this side we have motional EMF, electromagnetic induction by changing the orientation of the loop, mutual inductance and back EMF. So transformer we know works under the mutual inductance. Okay, so it is mutual induction, so option R is for transformer. Okay, Now what is AC generator? AC generator works on the electromagnetic induction by changing the orientation of the loop. So this will be Q, and self-induced EMF is back EMF, so this will be S, and EMF induced in a rod moving in a magnetic field is motional EMF, so this will be P. Okay, now in such cases, if this is a just example problem, this is an easy question. In some cases there will be a new match the following type of question, where you might face difficulty to match the options. So try to find at least one or two that you can match. If you can find at least one or two and then you check the option, you might find that that combination is unique. For example, I first started with transformer. Transformer works on the mutual induction, so this is the correct match. Now if you see that only after doing that match I found that this option is correct, because no other options given D matching with R. So if you are lucky, if you can find at least one or two correct matches, then you may not need to know all the other matches. So that is a trick that you have to remember. Okay, this is a simple trick, because in exam you do not know which kind of match the following type of question will going to come. Okay, there is a possibility at least one match the following question will be coming in your exam. So be prepared for it, and don't be afraid if you are not able to match everything. You try to find at least one or two matches if that is possible, and then you check if the option is unique for those matches or not. So that is a trick. Yes, I hope most of you have answered correctly. Yes, Rocky, Manshi, Srushti, Jia, Distortion, Kiran. So everyone is correct. Now let's move on to the next question. The average power dissipated in an AC circuit is maximum if the AC source is connected. So average power dissipated, and that is maximum if the AC source is connected only to pure resistor, only to pure inductor, only to pure capacitor, to a series combination of capacitor and inductor. So which of them is correct? Now we know that in AC circuit, average power dissipated across inductor and capacitor both are 0. So they do not consume any power. Okay, they only try to produce any resistance. They have inductive reactances and capacitive reactances, but their power consumption is 0. They do not consume any power. Only pure resistor consume power. So correct answer for option A, question 8 is option A. Why D? Why D, everyone? Kiran, Sumit, Jia. No, D is not correct. Series combination of capacitor and inductor, there is no resistor. That means capacitor and inductor both individually will be consuming 0 power. So 0 power is not maximum. Okay, so only pure resistor will be the case where power consumed is 0. Power consumed is maximum. So there are two options, either pure resistor or LCR in resonance. Okay, in these two cases, the power consumed will be maximum. Power consumed will be maximum when it is a pure resistor or it is an LCR circuit, but the circuit is in resonance. Okay, so if the same question is asked in a series LCR circuit, the maximum power is consumed on the resistor, on the inductor, on the capacitor when the circuit is at resonance. So you have to understand, when the circuit is at resonance, the maximum power is consumed in an LCR circuit. So LCR circuit, maximum power consumption happens at resonance. Otherwise, it is only to a pure resistor where power consumption is maximum. Clear? Right? Hope your doubts are cleared. Now let's move on to the next question. The displacement current is due to flow of electrons, flow of protons, changing electric field, changing magnetic field. So what is displacement current? So if you remember charging of a capacitor, so when we connect the capacitor across a battery, what happens is that the charges flow up to this point, but here there is no conductor. So charges are coming from this side and it is exiting from this side. How it is happening? Because there is an electric field developed between the plates, and that electric field is changing as long as the capacitor is charging, and because of that changing electric field there is a current flowing, and that current is called displacement current. Okay, ID is given by epsilon naught dE by dt, rate of change of electric field. Okay, so this is the displacement current, and displacement current is due to the changing electric field, not magnetic field, not due to flow of electrons. It is only due to changing electric field. Yes, correct. Option C is correct. Now let's move on to another question, another hot question. Okay, the net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving the surface is balanced by number of lines entering it. Okay, so if you consider any surface, any closed surface, okay, number of field lines entering is equals to number of field lines exiting, and that's why the net flux here is 0. Net magnetic flux is 0. Electric flux is not 0. And now the same question can be answered two ways. As I mentioned, the statement 2 can be two different statements. One of the statement obviously, so this is the correct statement. Okay, and second statement can be because no magnetic monopole exists. That can also be a correct explanation for this problem. Okay, and this number of field lines entering, the number of field lines exiting are same because there is no magnetic monopole exists. So both statements are true, and statement 2 is correct explanation of 1. So option A is correct. But you should remember that if the same question is asked with saying that statement 2 there is no magnetic monopole, that can also be the correct explanation of statement 1. Okay, so that is also a correct explanation. Yes, yes, correct. Kiran, Ashia, Blossoming Flora, Ashwin, Rahasya, Jia, Dharani, all of you are correct. Now next question. The electromagnetic waves with lowest frequency among the following are gamma rays, UV rays, microwaves, radio waves. This is a interesting question. You have to identify lowest frequency. Lowest frequency means wavelength higher. Okay, so if you remember that you have to remember the table. Gamma ray, okay, gamma ray, this is the symbol for gamma. Okay, gamma ray, X-ray, UV ray, then we have visible light, then we have infrared, then we have microwave, and then radio wave in general. Long radio, short radio are there, but radio waves in general. Okay, so this is the order you have to remember. This one will have highest frequency. Okay, frequency is highest, and this one will have highest wavelength. Frequency decreases here and wavelength decreases in this direction. Okay, so this will have highest wavelength, and as you are going up, wavelength decreases, and as you go down, frequency decreases. Okay, so in this option, obviously gamma ray has highest frequency. UV ray is next in the line. Microwave is little below, but still more than radio wave. So radio wave has the smallest or lowest frequency. Okay, it has highest wavelength but lowest frequency. Okay, so option D, question 11, option D. Satish is saying, please take my name. Hi Satish. Yes, answer questions, I will take your name. Okay, so this stop spamming. I took your name, right? Now next question. Current density is a scalar and SI unit is ampere meter square. Vector, it is a vector and SI unit is ampere per meter cube. Vector and SI unit is ampere per meter square. Scalar and SI unit is ampere per meter. This is a question came in 2024. Okay, 2024 final exam, PUC exam, this question was there. Okay, so what will be the answer for this question? 12C, 11C is already done. 11C is not the answer, 11D is the answer. If you are answering 12C, yes, it is correct. So vector and SI unit is ampere per meter square. Remember, current density, current is not a vector quantity. Current is not a vector quantity, so there is a thing that current, even though it has some sense of direction, it is not a vector quantity because it does not add up to vector addition rules. It does not follow vector addition rule. That's why current is not a vector quantity, but current density is a vector quantity. Okay, and its unit is ampere per meter square because current density is given by J equals to I upon A. So I is ampere and A is meter square, so ampere per meter square is the unit of current density. Next, a straight conductor of length L is moving with a velocity V in the direction of uniform magnetic field of strength B. The magnitude of EMF induced between the ends of the conductor. So there is a conductor of length L. Okay, this is a trick question. This is also can be considered as a horse question. Okay, do not answer BVL without reading the question, because you think, okay, this is a motional EMF, BVL, there is a possibility it could be 0 as well if the velocity and magnetic field are in the same direction. So make sure you read the question 2 times. Okay, many students just read the question once and then think motional EMF, this is BVL or BLV. No, read the question once more. Okay, with the velocity V in the direction of uniform magnetic field. So velocity vector and magnetic field vector, they are in the same direction. If they are in the same direction, their cross product will be 0. So in this case, magnitude of induced EMF is not BVL but 0. So make sure this is where you may lose your marks. This type of questions, even though it's very easy, but you see that only half of it, a rod is moving in a magnetic field. We know that it's a motional EMF, BVL must be the answer. Don't do that. Read the question once more, that they are moving in a same direction. Okay, in the direction. In the direction means B and V are in the same direction, and from Lorentz forces, we know that if B and V are in the same direction, force acting on it is 0, and because force acting on it is 0 means induced EMF will also be 0. Okay. Yes, I have taken questions from across different previous year papers, model papers. Model papers I don't remember, but yes, previous year papers I do remember some of the questions which are tricky in the model paper, previous year papers. If it is from model paper, it is well might be. Yes, we have taken questions from question bank, model paper, from where we will source the questions. Okay, that is your board has given so much options for your preparation, so that's where we are, from there we are taking all the options, right? Now let's move on to the next question. An object of finite height is placed in front of a concave mirror within its focus. Okay, a concave mirror is there, an object is placed within its focus. Okay, then what will be the image formed? Real and enlarged image, real diminished image, virtual enlarged image, a virtual diminished image. Okay, so those who have answered 14A, please check your answer. 14A is not answered, Gia, and someone answered 14D as well. Okay, 14C is correct answer. 13, my mistake, 13C, those who have answered 13A are wrong. 13C. Banna Kafi is saying, sir, KC 90 batch, when will first PU syllabus will be started? Ban Kafi hai, 3 ban kafi hai. We will start immediately after your PU exams are over. The PU1 chapters will be covered immediately within 1 week. Okay, don't worry, we have that. See, we are the teachers, right? We have more tension than you. Okay, we have to take YouTube classes, we have to take the batch classes, so there are that is upon us. We will close it as soon as possible, as soon as we get the time. Once your PU exams are over, we will give you PU1 lectures, don't worry. Okay, now next, So it's a virtual and enlarged image. Option C, not real and enlarged image. The distance is less than focal length. The object distance is less than focal length. That means it is within the focus. Within the focus means it forms a virtual and enlarged image because it's a concave mirror. Okay, if it is a convex mirror, it does not matter. Convex mirror always forms virtual and diminished image. But for concave mirror, if the distance is less than focal length, it forms a enlarged and virtual image. If it is exactly at the focus, it forms infinitely large image at infinity. Okay. The ferromagnetic material among the following is copper, nickel, lead or calcium. Okay. So copper, nickel, lead or calcium is the option. Only one of them is ferromagnetic. So which is ferromagnetic? 15B, yes, nickel is ferromagnetic, copper is diamagnetic. I am not sure about lead, calcium is paramagnetic. Okay, so this is the thing. Nickel is only ferromagnetic. Now next question, easy question. So I hope all of you have get it. Nickel, cobalt and iron are naturally occurring ferromagnetic substance, and one more, gadolinium is there, but gadolinium is slightly tricky. You should not know the name. In a purely capacitive circuit, if the frequency of AC is doubled, the capacitive reactance will get doubled, becomes 4 times, get halved, remains constant. So if you increase the frequency twice, what will happen to the capacitive reactance? Capacitive reactance or XC is given by 1 by 2 pi frequency into capacitance. Okay, so if you increase the capacitance to 2 times, then the capacitive reactance will be halved. Okay, if you increase the frequency twice, then capacitive reactance will be halved. So get halved is the correct answer. Okay, option C is correct answer. Okay, Shankar, so you are saying take my name, sir. You are saying, okay, my name is Shankar. Shankar, hi, welcome to Deeksha, Karnataka. Okay, now next question. Shankar, try to answer the questions as well. I will take your name by default. Okay, those who are answering, I am taking their names turn by turn. I am planning to close the MCQs as soon as possible, then we will move on to the more important numerical section. The power factor of a series LCR circuit is maximum. Okay, so this is a similar question that we have answered. Average power dissipated and power factor, they are same. Okay, and I give you a hint at that question when the power is maximum. So if average power is maximum, power factor is also maximum. So when is the power factor maximum? XL equals to XC, XC not equals to XL, XL greater than XC, XL less than XC. Quickly answer this question. I will take the names, whoever have answered it correctly. Okay, so A17, A17A distortions. Rocky is saying A, Mansi is saying A, Samarth saying A, distortion is saying 17A, Rahasya Chinu A, Blossoming Flora A, Gias A, Dharani option A, Kiran Kumar C. Kiran Kumar is saying C. Okay, Sriban Kafiya is saying A, Aisha is saying 17A, Rahasya Chinu again A. So here, so power factor is maximum when maximum power is dissipated in the circuit, and maximum power is dissipated when circuit is in resonance or it is a pure resistive circuit. Either it is a pure resistive circuit or circuit is in resonance. So only when XL is equals to XC, circuit is said to be in resonance. Circuit is in resonance means maximum power is dissipated, power factor is 1, cos phi is called power factor, cos phi becomes 1. So this is the correct answer. not C, not D, not B, but option A. Okay, so this is the resonance condition. If you identify that this is the resonance condition, you should be able to answer this question. Next, which of the following phenomenon confirms the transverse nature of light waves? Polarization of light, diffraction of light, dispersion of light, or refraction of light. So wave nature, not wave nature, transverse nature. So if they ask you wave nature of light, all of the things are displayed by any waves. So that's why it is all of them are, not all of them, mainly 3 of them are displaced by all the waves. So those 3 you can answer, but here one option is given which is unique to a transverse wave, which is unique to a transverse wave, that is electromagnetic waves mainly are transverse wave. And there are another type of transverse wave, mechanical waves can also be transverse, but that is only shown by transverse wave, not any other types of waves. Shankar, I took your name 5 times, try to answer the question. I will take your names once more. So Dhanaya 18A, Deepti option A, Jia option A, Mansi option A, Blossoming Flora option A, Deepti A, Dharani A, Kiran Kumar A. Yes, it is polarization of light. Okay, polarization is shown by only transverse wave, remaining all 3 are shown by all types of waves. Okay, including sound wave. Sound wave shows diffraction. While both light and sound show wave character, diffraction is much harder to observe in light. This is because, so diffraction of light is much difficult to observe, but sound wave easily show diffraction. So for example, if you call someone from behind a wall and you are standing behind a wall, someone is staying on the other side of the wall, if you call by her name, hi Shankar, how are you? So Shankar will be able to hear his name from the other side. Why? Because sound wave is actually diffracting through the wall, top of the wall, because it has a very large wavelength and we sometimes ignore it. We think it is very natural. Okay, actually the thing that is happening is that when you are talking from behind a wall, sound wave which is generating over here, it can easily go up and it can go to the other side because it has a very large wavelength. Okay, but that is not possible for light wave, because light is very small wavelength, so you need a very small aperture of the order of the wavelength so that you are able to observe diffraction. Very important is that the obstruction should be of the order of the wavelength. That means the suppose wavelength is 200 nanometer, then you need a 400, 500 or 600 nanometer gap to observe diffraction. If you have 1 meter gap, it will not be showing you any diffraction. So because wavelength of light is far smaller, we require much sophisticated instruments to observe diffraction of light. Yes, Shri Raksha, Mansi, Blossoming Flora, Kiran Kumar, Rahasya, Blossoming Flora, Rocky, Jia, everyone is correct. Option C is correct answer. Now next, the gathering and focusing mechanism of light by eye lens is described by. You might see that, you might feel that this is not part of the syllabus. Actually, if you read your NCERT textbook very deeply, you will find this question, answer to this question as well. So this is taken from your NCERT book as well. The gathering and focusing mechanism. There are 2 mechanisms that happens in our eye. First is gathering the light and focused into the retina, and then retina takes that light and then it transport to your brain. Okay, our optical lobe is behind our head. Okay, so the signal taken by our eye, that is being transferred by the retina into our optical lobe, and that's how we see things. Okay, so first thing is gathering and focusing, second is absorbing and transmitting it. Okay, both have 2 different properties of light. Okay, wave nature of light, particle nature of light, both A and B, neither A nor B. So which one is correct? Gathering and focusing is one, absorbing and transmitting is second one. So 20A, Aisha is saying 20A. Okay, Deepti is saying 20A, Sri Raksha is saying 20A, Kiran Kumar is saying C, Satish, Shankar is saying C. No, Shankar, option C is not correct. Okay, gathering of light and focusing it into the retina is only possible because light behaves as wave. Okay, so gathering and focusing is based on wave nature, absorbing and transmitting is based on the particle nature. Okay, so when the retina absorbs it absorbs quanta by quanta. Okay, and that quanta is now transmitted in the form of electrical signal to our optical lobe. So gathering and transmitting happens on the particle nature of light, but sorry, not gathering, absorbing and transmitting happens by the particle nature of light, whereas gathering by our retina, by our eye lens, and then it is focusing into our retina, that is basically wave nature of light. So light behaves as wave and particle. That's why we are able to see things. That is why you are able to see me right now, because your eye is doing it automatically. Okay, the slope of stopping potential V0 versus frequency nu in Einstein's photoelectric equation. This is also a hot question. Okay, this is also a hot question. The slope of stopping potential V0 versus frequency nu in Einstein's photoelectric equation. So if you write Einstein photoelectric equation, E V0 equals to H nu minus phi naught. Okay, so V0 is the stopping potential, nu is the frequency, and phi naught is the threshold energy. Okay, or cutoff energy, that is minimum energy required to get a light, right? So from here we can say that V0 equals to H by E into nu minus phi by E. Okay, phi naught by E. Now if you compare y equals to mx plus c, so you will see that in this equation, this is the equation of a straight line, right? The slope of the graph can be compared. So we are plotting this versus this, so y versus x. So this is y, this is x. So the slope of the graph must be h by e, and the intersection must be minus phi naught by e. Okay, so if the same question is asked, what is the intersection? Intersection will be minus phi naught by e. Okay, but the slope is h upon e. The slope is h upon e. Option B. Sir, you already did MCQ session, why you are doing it again? Luxury finds. We are doing MCQs. As I mentioned, I will be doing more MCQs for your practice, so that you can get understand what type of mistakes you are making. But this session is not only MCQs. Here we will be doing much more than MCQs, 30 MCQs, and then much more other type of questions as well. Please be patient, because I believe 2-3 marker question are easy to solve. I will give you one session of consisting of all 2-3 marker. You can go and check that out. That will be recorded format. That will sufficient for all 2-3 markers. You lose your marks not in 2-3 marker question. You lose your marks in MCQs, in numerical questions, and somewhat in derivation if you do not write the steps properly. So those 3 portions I will be explaining in today's lecture. There will be one exclusive lecture of all 3 model papers. So do check that out, where I will be discussing all 3 model paper in one video. And there will be an exclusive lecture for numerical videos as well, live. Okay, so I am practicing MCQ questions, so that because you do not lose marks, you should understand how the same MCQ being asked in a separate way and where you are making the mistakes. That's why I am doing the MCQ session once more. This is not full-fledged MCQ session, by the way. It's just a practice. The alpha particles are hydrogen atom, hydrogen plus atom, helium plus 2 atom. Okay, now let's see who can answer this. Aisha, according to blueprint, yes, they will set the paper, but in this blueprint they have not given distinct identification that from this last year. If you see the last year's blueprint, they have given 3 different blueprints for different papers. Okay, this year they have given one consolidated blueprint, where they have not mentioned that from this chapter you are expecting a numerical, from this chapter you are expecting a 5 marker, from this chapter you are expecting a HOTS question. So that bifurcation is not there in the blueprint. They have given overall blueprint. From all the chapters you are expecting one new MCQs, except one chapter where you are expecting 2 MCQs. Similarly, all the chapters are given 5 marker sections. From this chapter chapter. Current electricity, we can say that one numerical, one theory will come, because 2 5-marker question is there. Otherwise it is not clear from which chapter you are going to get numerical, which chapter you are going to get derivation. Okay, so that's why numerical, the blueprint is not foolproof. Okay, so if you just read, okay, there is a 5-marker question mentioned, I will practice only derivation, in the exam they will see a numerical question. So that's one thing. First 5 to 3 marker question. First 5 to 3 marker, I am not getting your point, Darshan. Yes, 2-3 marker question will come very, very soon, in another 2 days. Sridaksha is saying, explain power dissipated topic. Power dissipated in what? In AC circuit. Power dissipated in AC. Sridaksha, can you please confirm? This answer is D. Yes, answer is D. Remember, helium plus 2 atom is alpha particle, not helium. Okay, once the MCQs are over, I will take a small Q&A session where whatever your questions are there, I will take it up. Okay, please wait. 23, wait for 7 more questions. So once question number 30 is reached, I will take up all of your queries and I will take a small Q&A session if you have any doubts in any concepts. According to Louis de Broglie, waves associated with orbital electrons are progressive wave, stationary wave, longitudinal wave, continuous wave. So only one of them is correct. Yes, Darshan, this is for most expected question. 2-3 marker question, I believe, are very easy. I should not waste time on 2-3 marker question. Coulomb's law, okay, Lorentz force, etc. They are mostly theoretical questions, and theoretical questions are not too much required of my attention. I will give you the questions, I will give you the answers as well, but not in this lecture today. Okay, 2 and 3 marker question I will give you another 2 days. So please be patient. There I will be discussing all 2-3 marker questions at one go. Okay, sometimes 2 marker question can be asked as a 3 marker question, and all of them are theory question except one numerical on 2 marker, one numerical on 3 marker. Okay, I will give you some 2-3 marker numerical questions as well, but do not waste too much time on 2-3 marker, because your marks are being gone only on MCQs, your marks are gone only on numerical questions. So put a little bit more effort on these. I will be whatever MCQs I am discussing are all very, very expected. Okay, all the numericals I will be solving today are all very, very expected questions. Okay, so don't be disappointed if I am not doing 2 marker, 3 marker question. I am doing it for your own benefit. Darshan, I will give you 2-3 marker question, don't worry. Okay, your current electricity power dissipated topic for 2 minutes. Current electricity power dissipated. Okay, understand. I'll give you. Just answer these questions quickly, and Darshan, please stop spamming. Option B, yes, stationary wave is correct answer. Current electricity power dissipated coming just in 2 minutes. If Mn and Mp represent mass of neutron and proton respectively, if an element having atomic mass m and n neutron and z number of proton, then the correct relation will be. Which of them is correct? Now remember, this is a physics theoretical subject, and numericals are there as well. If it is a mathematics where you are solving all the numerical questions, 2-3 marker questions make sense. In physics, 2-3 marker questions, there will be hardly one student in 100 who will do the one numerical. Otherwise, most of you will write the theory answers. I will explain all the theory answers in a crisp small video so that you don't waste too much time on 2-3 marker question. Okay, so there will be almost 70-80 2-3 marker question I will discuss in one go. You can check that out. Okay, within 2 hours I will complete that video, and that will be sufficient for all of you. M and MP are represent mass of neutron and proton respectively if an element having atomic mass capital M. So atomic mass capital M is always less than total mass of the neutron, mass of neutron plus mass of proton. Okay, it is always less than total mass because that is called mass defect. So correct answer is option A. Okay, next, radioactive substances emit alpha rays, beta rays, gamma rays, all of the above. Okay. Okay, Megha, I will keep that in mind. Meghna, I think Meghna, we will keep that in mind. We will try to make most important questions for Hindi, at least few videos on Hindi as well. Okay. Should 50 questions, can I score 65 marks? Sir, please tell me, sir. So these 50 questions, you can score up to 40 marks. Okay. There are 15 MCQs. 10 marks numericals and 15 derivations. So 30 plus 10, 40 marks you can score from if you watch this 50 questions. Okay. So 25 questions, what is the answer? G not B. Those who are answering B, no, not B. Okay, radioactive substances emit alpha rays, beta rays and gamma rays. So all of the above is the correct answer. Okay, there is only a very small radioactivity there in your chapter right now. Previously it used to be a very long concept. Okay, now everything is deleted, only the radioactive emissions are there. Alpha ray is the charged particle of helium, beta ray is electrons, and gamma ray is high energy electromagnetic radiation. Okay, all of them are actually emitted by radioactive emissions. So this is the correct answer, all of the above. A semiconductor doped with a donor impurity. Donor impurity is p-type, n-type, npn type, pnp type. Okay, npn and pnp are obviously not there in your syllabus. So either p-type or n-type. What is the semiconductor doped with a donor impurity? So they have not given whether it is a trivalent or pentavalent. They have mentioned donor impurity. Donor impurity means it gives electron. Okay, donor means it gives electron, that means it's a pentavalent. Donor is pentavalent. Okay, pentavalent is donor impurity and acceptor impurity is trivalent, which is actually accepting an electron. So donor impurity is which is donating extra electron. So that means it must be a n-type semiconductor, not p-type. Okay. Yes, Darshan, you can do that. I will be doing an updated version of that in another 2 days, so you can definitely check that old version. Okay, there I have done it for last year students. You can check the 2-3 marker for your pre-board. Pre-board one was much better. I will be doing an updated version of your all 2-3 marker questions for this year, because some questions which repeated last year will not come this year. So those questions I have to filter it out, and then I will give you a much more updated version of 2-3 marker. Okay. So that's why I'm not discussing 2-3 markers in this session. Semiconductor, okay, this one is done. Now which of the correct diagram of a full wave rectifier? Which of the following is the correct diagram of a full wave rectifier? Okay, full wave rectifier. Which of the following diagram represents the correct diagram of full wave rectifier? Now if you see the diagram, one thing is for sure is that in a full wave rectifier we need 2 diodes. One diode is not sufficient for a full wave rectifier. So none of these are a full wave rectifier. Okay, because all of these cases we have only one diode. Here we have both diodes, but if you see that one diode is this way, one diode is this way, that nothing to do. So when this diode is forward biased, this is conducting. When this diode is reverse biased, it will not conduct, but when it is forward biased, it will conduct in the opposite way. That's why even though diagrams are not proper, it is taken from your question bank. The diagram is slightly misleading, but you have to understand that in a full wave rectifier we do need 2 diodes. One diode is not sufficient for a full wave rectifier. So correct answer will be option A. Okay. Now next, n-type semiconductor is electrically positive, negative, neutral. As temperature increases, it becomes negative. Aisha, full wave rectifier requires 2 diode, okay? So even if you think that there is no option, actually the circuit is slightly misleading. When the this side is positive, this side is negative, okay? This diode does not conduct if this is okay. So basically what they have said, here we have a capacitor, so it says that this side is positive, this side is negative, so this diode is forward biased, and in the next cycle what happens is that this is negative, this is positive, next cycle this becomes negative, this becomes positive, so this is conducting, this diode is conducting, this is not conducting, so again the diagram will flip and you will get a full wave rectifier. Even though yes, I agree with you that none of them are actually completely correct, okay? So it has to be 2 diode, that's why I am choosing option A, okay? Anyway, N-type semiconductors are electrically 28B negative, okay? Anyone else? Kotrappa, what is your question? Kotrappa, I don't find your question because Darshan has almost spammed the chats. Roy Forns, yes, this will be available in form of PDF. Should 50 questions can score 65 plus. Which 50 questions, Kotrappa? This 50 questions is, as I mentioned, is for 40 marks, okay? This 50 questions we are discussing today will give you 40 marks. If you understand how to solve a MCQ, MCQ is not just only memory based. There is a process of solving MCQs. If you understand that, then you will be able to answer the 15 MCQs in your exam as well. And we will be solving numerical questions as well. So N-type, P-type, P-N-type does not matter. All types of semiconductors are always electrically neutral. So that is why I always say that don't lose your focus. Focus on the question. N-type semiconductors does not matter N-type, P-type or PN junction. All the semiconductors are by default electrically neutral because you are not adding any extra charge. What you are adding donor atoms or acceptor atoms. In case of P-type, you are adding a complete full atom. Full atom is electrically neutral. The silicon was there, that is also electrically neutral. So neutral is not actually creating any extra charge. Only thing that is happening, that donor atom has one extra electron that more than that required to form a bond, so that electron it is releasing. But there is a positively charged ion sitting at the crystal itself, and that's why the total charge is still 0. So N-type, P-type does not matter, they are always electrically neutral, okay? N-type, P-type, P-N-type, they are all always electrically neutral. This is a very common mistake students make. N-type they think negative, P-type they think positive, but actually they are always electrically neutral, right? In the equation A equals to BC, A is current density. This is another hot question. A equals to BC, A is the current density, C is the electric field, then B is easy question. So we know that it is basically coming from J equals to sigma E, but it is given with a twist. E is equals to sigma J by sigma, that is rho into J. Rho is resistivity, right? So from there we can say that A is electric field, okay, C is current density, then B must be resistivity, okay? So it is resistivity, option A. Next, a rectangular coil carrying current is placed on a non-uniform magnetic field. On the coil, the total force is non-zero, force is 0, torque is 0, none of the above. Answer the question number 30. I will have some water and then I will explain the power dissipated in a circuit. Option A, yes. So rectangular current carrying coil can be considered as a magnetic dipole, okay? So based on its direction of current, either it will be into the page or out of the page, okay? So it can be considered as a magnetic dipole. A magnetic dipole placed in a non-uniform magnetic field. Torque is obviously not zero and force is also not zero. Non-uniform magnetic field, force is not zero, torque is also not zero, okay? But if it is a uniform magnetic field, force will be zero, torque will be not zero, okay? But here, because it's non-uniform, torque and force both will be not zero. Now let us move on to the portions that you are asking. Power dissipated in an electrical circuit. So what is the power dissipated in a normal electrical circuit? So here we have a resistance. In current electricity, only resistance is there, okay? We have a battery. I am assuming ideal battery only, okay? Real battery does not make any other sense other than you have to take the total resistance. Suppose the current in the circuit is given by I, the resistance is R, the voltage of the battery that you have applied is V, okay? Now if you are not aware of the voltage, you only have a resistance, and if you know the current through that, okay, so this is also sufficient information. If you know the current, if you know the resistance, you can calculate the power dissipated. In some cases, there will be a circuit related question where they will ask you, what is the power dissipated through this resistance, okay? So for the first part, you have to calculate the current through that particular resistance using KCL and KVL. That type of questions are also there, right? If you see your model paper, there was one question where you have circuit like this, right? If I remember correctly, there was a circuit like this. One cell was there on this side, one cell was there on this side, and there are some resistances, and they ask what is the power dissipated in the central resistance. So what you have to do, first step is to use KCL and KVL, whatever current that you are assuming, okay? Remember two things you have to understand. If it is a battery, if there is a battery connected in the circuit, whatever current exiting the battery, the same current has to come back to the battery because charges are conserved, okay? So if you see this kind of complicated diagrams, no matter how much complicated it is, if you see that the current is exiting the battery is I1, the same current I2 has to come back to the battery. So this is the first step, okay, for applying KCL and KVL. And what is the power dissipated? Power dissipated, if you can calculate the current through this resistance, then power dissipated is given by always I square into R, okay? In terms of current, it is I square into R is the power dissipated. In terms of, if you know the voltage, then it is V into I, Vodafone Idea, okay? So Vodafone Idea is power, or V square by R, okay? V square by R. So these are the three formulas that you need to remember for power dissipated related problems, okay? So power dissipated in a circuit is nothing but how much energy it is spending per second. Energy spending, if you remember joules heating in your class 10th, joules heating was given by I square R into T, okay? Or energy was vitamin VI into T, okay, or V square T into divided by R. So these are all the three formulas. Now if you take that T out, you get the power. If you take the T out, you get the power. Power is energy dissipated per unit time is called power, okay? So if you see a bulb, okay, power rating of a bulb, even though power rating of a bulb is not important for your PUC, but that might be coming in your KCET exam, just briefly I will discuss. So power rating of a bulb, if you see a power rating of a bulb, say 100 watt bulb or 100 watt light. So what does it mean? So if you connect it 100 watt, 220 volt. Voltage rating also has to be given. So if you connect this 100 watt bulb across a 220 volt supply, it will consume 100 watt power, okay? That is 100 joules per second the energy it will spend, okay? From this information you can calculate the resistance, you can calculate the maximum allowed current, you can calculate the resistance as well, okay? So how to do that? You know that this formula P is equal to I square R or P is equal to V into I. So V is given, P is given, you can calculate I. So a maximum current will be given by P divided by V, and resistance will be given by V square by P. Okay, so for a given bulb, if you remember, these are the formulas that you need to use for a bulb combination. That's it. Okay, so power is basically nothing but I square R or V into I or V square by R. Okay, and power means how much energy it is spending per second. Okay, clear? If you have any other doubt regarding anything else, you can mention. Sometime they give two batteries, sir. Okay, so in case of battery, it is basically epsilon naught I. Okay, epsilon naught I, epsilon into I. Epsilon is the EMF of the cell and I is the current that is required. Okay, if it is based on, say, this much power is required to establish the current. If they ask you how much power is being spent by the battery, power spent by the battery is epsilon I. Okay, so basically our epsilon is nothing but replaced by V. V into I, if you can calculate the current that is being given in the circuit. Suppose you have given a cell. Okay, suppose the cell is there. So you calculate the current. As I mentioned, the current that is exiting the battery, same current should come back. Okay, again apply KCL, KVL based on the circuit given to you. Calculate the current that is being passing through the cell, and the cell is actually spending this much energy, this much power. Even though not all of them are useful, because some of them are being absorbed by its internal resistance, but the cell is doing exactly this much amount of power, it is spending this much amount of power. Power spent by a cell is given by epsilon I. It does not depend on the terminal voltage. Terminal voltage power dissipated is on the resistance, and it is actually the useful power. Okay, the cell will expand cell will expend this much amount of power, but not all the power spent by the battery is useful if the battery has an internal resistance. So remember that. Okay, epsilon is the EMF of the cell, and I, that is the current passing through the cell, then epsilon into I is the power dissipated by the battery. Okay, so power dissipated by the battery, power dissipated by the resistance, all doubts are cleared. Okay. Okay, Arun Lamani, I think your you should check your device volume, because I am speaking with my loudest volume over here, and trust me, no one ever said me to raise my volume. Okay, because I am already so much loud. Okay, if I am take lecture in this lecture room, whatever rooms are nearby, they always say that, sir, you are taking class too much loud. Please reduce your volume. You are the first person that is saying me, sir, please raise my voice, because I believe my voice is the loudest among all the teachers. And if you are not able to listen to my voice, that means either your device volume is low, or you check your PC or Bluetooth device volume from where you are watching. Okay, now we will be moving on to very interesting part where we will be solving numerical questions. Now, before I start, I want to recommend at least 3 chapters from where you should practice numericals. Minimum 3 chapters. What are all those 3 chapters? Electric charges and fields, okay, electric potential and capacitance, and alternating current. These 3 chapters numericals are tentatively easy. If you practice few of the type numericals, you will be able to answer those questions. And if you are strong enough with circuit theory related questions, if you are someone who has practiced enough circuit theory questions, you can practice current electricity as well. Now, I am not going to discuss current electricity in today's lecture. If you are really interested in current electricity, I have done a long video, long live in our channel that is called Circuit Theory. You can do check that out. There I have solved various current electricity related different problems, and I will be still discussing them in a separate numerical video, numerical live. There will be a numerical live as well. If you are wondering, I think that is scheduled this Sunday. So there I will be discussing all types of numericals, including current electricity types of numericals as well. So do check that out as well. Today I am going to discuss most 3 important chapters from where you cannot skip. Okay, electric charges and field, electrostatic potential and capacitance. If you study these two chapters, one numerical pakka, and if you study alternating current, you will get another numerical pakka. If you want to have a backup, ray optics is also another chapter from where you can practice numericals. If you are not sure about ray optics, then you can practice current electricity. Okay, 3 chapters plus 1 for your buffer in case, for example, last year the question from current electricity, electric charges and field question was easy, but they make a typing error in that question and student got confused and they thought, okay, that there is a typing error, we will get bonus marks if I just write the question number. They did not try to solve it at all. Okay, so that one problem happened last year. So you have to be careful about those kind of mishaps as well. Consider a uniform electric field E equals to 3 into 10 to the power of 3 I cap Newton per coulomb. What is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to YZ plane? What is the flux through same square if the normal to the plane makes an angle 60 degree with the x-axis? Okay, so here we have an electric field given. We have given a plane which is YZ plane. Okay, YZ plane means the vector is along x-axis. YZ, so if you remember, this is x-axis. Okay, this is this is x-axis, this is y-axis, this is z-axis, suppose. Okay, x cross y equals to z. Remember this, according to right hand rule, x cross y equals to z. And z. Okay, so YZ plane is this plane. YZ plane is this plane. Okay, both one side is along y-axis, one side is along z-axis. So the normal to this plane will be along the x-axis only. Okay, so E and area vector are in the same direction in the first case. Okay, so the first case, the flux will be given by E into A itself. Okay, I dot I is 1. It's a scalar quantity, so no scalar vector will be there. I dot I will be 1. So if you can calculate area, electric field is given, you can calculate the flux. Now what is area? So area is 10 centimeter into 10 centimeter. It is a square surface of 10 centimeter side. Now whenever there is a centimeter, you have to convert it into meter. Try to use multiplying by 10 to the power of minus 2. That is much easier than putting decimal into the calculations. Okay, decimals will be tricky for you and you will not be able to solve it easily. If you put 10 to the power of minus 2, it will be very easy. So you will see that this will be 10 to the power of 2 minus 2. So only 10 to the power of minus 2 is there, meter square. So this is the area. Everything has to be in meters. Okay, unless you are solving ray optics question. In ray optics, centimeter is accepted, but in electric charges, field, electric capacitance, okay, everything has to be in meters. Now electric field is given 3 into 10 to the power of 3, and area we have calculated 10 to the power of minus 2. So flux will be 30. Now unit is very important. What is the unit? If you don't remember the unit, how to find the unit? What are the quantities that you are multiplying? You are multiplying Newton per coulomb and meter square, E into A. So unit must be Newton meter square per coulomb. If you don't know the unit, you have to find the unit yourself. Okay, now part B. In the part B, it is said that they are flux square the normal to the plane makes an angle 60 degrees. So normal to the plane makes an angle 60 degree means this angle is 60 degrees. So E, now flux, this is case number A, case number B, it will be EA cos theta. So it will be 30 cos 60. Now you don't need to do anything else because 30 part you have already calculated. E into A is 30. Okay, so it will be EA cos 60. Cos 60 is half or root 3 by 2, half. Cos 60 is half, so it will be 15 Newton meter square per coulomb. Okay, so if you see that 30 Newton meter per coulomb and 15 Newton meter square per coulomb. Okay, easy question. Don't sweat too much on this type of questions. If you know how to solve it, you will be able to answer those questions. Now next question, 2-point charges QA 5 microcoulomb, QB minus 5 microcoulomb are located at A and B separated by 20 centimeter in vacuum. It is almost like a dipole but not a dipole because the distance is slightly longer. Okay, so do not use the dipole formula if you are thinking. So this is 5 microcoulomb, this is minus 5 microcoulomb. Okay, the distance between them is 20 centimeter. What is the question? What is the electric field at the midpoint O of the line joining the charges? So we have to find the electric field at the midpoint. So midpoint means this is 10 centimeter, this will also be 10 centimeter. Okay, so now you answer this question, what is the electric field? First part is easy. Let's solve together and tell me the answer in the chat. See, my mic is here only, okay? My mic is perfect. Yes, bless Koshi, you will get the but we are getting low sound, sir, very less sound. Let me check. Yes, bless Koshi, you will get. See, I am hearing my voice in my mobile, which is very loud to me. Okay, you should check your device sound once. Okay, you should check your device sound once. Maybe it is low. Okay, I have increased the volume as much as possible from here in my end. If you still are not able to hear, please check your device volume once. Okay, your device volume once, because from my mobile when I hear my voice, it is perfectly loud and clear. Okay, yes, thank you, Aisha. Now if you see that 10 is coming over here. Okay, so you have to calculate the electric field. 31B, 15, yes, distortion is correct. Option A, 10 Newton per coulomb. Okay, let's see. So electric field at point A, electric field at midpoint will be exactly. Now if you see that, first of all you have to understand electric field due to the positive charge will be in this direction. Electric field due to the negative charge will be again in this direction. So both will be added. Now when you calculate electric field, do not use the sign of the charges. I always say this to my students, do not use sign of the charges. Sign of the charge is not important when calculating the electric field, but what is important is the direction of the electric field. Okay, so E is KQ by R square. The formula is very easy, but in this Q, do not use the sign of the charge. If you are calculating potential, use the sign. If you are calculating electric field, do not use plus or minus in the charge. Okay, direction is important. So as you can see, this is positive, this is away from, this is negative, this is also in this direction. So electric field actually will be for plus and minus, both will be in the same direction. So and both of them will have the same magnitude as well. Why? Because both of them have same charges and same distance. So the net electric field is actually addition of these two electric fields. So that means net electric field is twice of KQ by R square. Okay, now put the values. 2 into K is 9 into 10 to the power of 9. Q is 5 microcoulomb, 10 to the power of minus 6, and the distance is 10 centimeter. So 10 centimeter means 10 into 10 to the power of minus 2 whole square. Okay, so now let's solve. We get 2 5s are 10, so 9 into 10 to the power of 10 minus 6, 10 to the power of 4 divided by 10 to the power of minus 2. Okay, 10 to the power of minus 1 whole square, 10 to the power of minus 2. So it will be 9 into 10 to the power of 6. So the net electric field is 9 into 10 to the power of 6 Newton per Coulomb. Okay, it will be 9 into 10 to the power of 6 Newton per Coulomb. So not 10, I did not get 10 Newton per Coulomb. Yes, distortion is correct. Now second part, part B, is if a negative test charge of magnitude 2 Newton nanocoulomb is placed at O, what is the force experienced by the test charge? Force experienced by the test charge is actually Q into E net. Okay, Q is 2 nanocoulomb, so 2 into 10 to the power of minus 9 and multiplies by the electric field, so 9 into 10 to the power of 6, so it will be 18 into 10 to the power of minus 3 Newton. Okay, so as you can see that questions are not difficult. If you the calculation wise, if you talk about calculations, if you talk about the formulas, they are all easy. Only thing you have to understand, electric fields are in the same direction, that means they will be added. We will solve one more similar question with slight different values. So answer is 9 into 10 to the power of 6 and 18 into 10 to the power of minus 3. Both cases distortion is correct. Now let's move on to the next question. Similar question with a slight variation. 2 point charges of plus 2 nanocoulomb and plus 6 nanocoulomb are placed at the points A and B respectively, separated by a distance 0.2 meter in air. Find the magnitude of the resultant electric field at the midpoint O of the line joining A and B. What will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is added to plus 2 nanocoulomb charge? Okay, so this is also one of your previous year paper. Okay, I don't remember the year, but this is also taken from your previous year paper. So plus 2 nanocoulomb and plus 6 nanocoulomb. Okay, this is at A, this is at B. Now if this kind of questions are being asked, no, always draw the diagram. If you don't draw the diagram, teacher will feel that you have copied it from someone else, and teacher will if for small mistakes also, teacher will heavily punish you. So try to draw the diagram properly and then try to solve it. Even if you make small mistakes, teacher, the examiner will give you small concessions, thinking that you have solved it yourself. So small mistakes can be ignored. But if you do not draw the diagram, teacher will think, okay, he or she must have copied from someone else, so I will punish heavily for small mistakes as well. Okay, and because obviously you require the diagram to solve such questions, what students do, I have seen, they draw the diagram in their question paper and solve the answer in the notebook. They won't do that. Okay, you have to show the diagram to the examiner that you are solving it by yourself. So the diagram is compulsory to draw in the answer sheet itself. Don't draw the diagram in question paper and answer in the answer sheet, because for diagram also you get marks. Okay, so draw the diagram in the answer sheet clearly. Okay, so don't make that mistake. So again, the total distance is 0.2 meter. So this will be 0.1 meter. This will also be 0.1 meter. Okay, so this is one very important tip from my side, that don't forget to draw the diagram. Now the distances are already given in meters. Now here this is positive, this is also positive. So electric field due to plus 6 will be in this direction. This is plus 6. And electric field due to plus 2 will be in the opposite direction. Okay, both of them have separate charges. Okay, so E6, so first part A, E6 is given by KQ1. Now I am also teaching you another trick that you can use in the exam. Okay, if you start calculating everything from the beginning, that is also fine. If you use this trick, that is also okay and fine. Okay, distances are same. because you are doing it at the center. So 0.1 meter, 0.1 meter. So I am keeping R same. What about E2? E2 will be K Q2 by R square. Distances are same. This is 6, this is 2. Now what? As I mentioned, 6 is on this side, 2 is on the other side. That means 6 is bigger because obviously magnitude is bigger. So net electric field is given by E6 minus E2. If you are not comfortable with this method, you can directly calculate the value by putting the values directly and calculate it. If you want to save some time, use this method. Okay. Now what is the method? K by R square. If you see these equations, K by R square is common. We get Q1 minus Q2. Okay. This is the shortcut method. So now put the values. 9 into 10 to the power of 9 divided by 0.1 whole square into 6 nanocoulomb minus 2 nanocoulomb. 6 minus 2 means 6 minus 2 nanocoulomb. So nanocoulomb you have to convert it into coulomb. So 10 to the power of minus 9. 10 to the power of 9 minus 9 cancels, and we get here the net electric field as 9 by 10 to the power of minus 2 into 4. So it will be 36 into 10 to the power of 2 or 3600 Newton per coulomb. Okay, so this is the part where you calculate the electric field due to the combination of charges at the midpoint. Now if you use this method, then the part 2 answer will be very, very easy to explain. Okay, otherwise you have to write a lot. Now what will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is added to plus 2 nanocoulomb? So if you add plus 4 nanocoulomb, then Q2 will be plus 2 was already there, and you have added one more plus 4, so it will be 6 nanocoulomb. So now what will be the net electric field? Net electric field will be K by R square Q1 minus Q2, that is K by R square 6 minus 6, that is equals to 0. Okay, so the net electric field in the second case will be 0 Newton per coulomb. Now even if you are writing 0, try to write the unit as well, because electric field, even though it's 0, it has a unit. Okay, so the first answer is 3600 Newton per coulomb, second unit is 0 Newton per coulomb. Okay, understood? Any doubts? Yes, 0. B is 0. Sir, we have optics numericals. Shankar, you have optics numericals, but it is not guaranteed that numerical will come from ray optics. But yes, either ray optics or wave optics, one numerical will come. I am not doing it today. I will be doing all very important numericals on my next live. I think Sunday there is a live. There I will be discussing all the, now Sunday I think model papers are there. And one Sunday after Tuesday is all numerical. So don't forget to join me on next Tuesday. There I will be discussing all types of numericals, including current electricity. But that day I will be discussing less electric charges and field numericals, more towards current electricity, ray optics, wave optics, all different sorts of numericals we will discuss. Don't worry, just not today. Two positive charges. Today we are mostly focused on the common chapters from where you are supposed to solve the numericals, and that are easy. Trust me, these are easy numericals. Okay, electric charges and field, electric potential and capacitance, just formula based numericals, and you should be able to solve the questions. So formula based numericals are easy because you don't need to think too much, and it is not dependent on your personal skill. For example, current electricity, you have to draw the diagram, you have to understand the diagram, how it is happening, how to take a loop. So that can be complicated at times. But here you know the formula, KQ by R square, KQ by R, and based on that simply most of the problems can be solved. Two positive charges of 0.2 microcoulomb and 0.8 microcoulomb are placed at a distance 0.15 meter apart. At what point on the line joining them the electric field is 0? So here we have two charges, both of them are positive, 0.2 0.8, and you are trying to find electric field is 0. So electric field will be 0 between the charges. Okay, if both of them are positive, electric field will be 0 between the charges, and it will be closer to the smaller charge. It will be closer to the smaller charge. Initial distance was given 0.15 meter. Suppose the distance from the smallest charge is x meter. Okay, distance from the smallest charge is x meter. So electric field due to 0.8 is in this direction, electric field due to 0.2 is in this direction, and they will be equal and opposite, so that they cancel each other. Net electric field will be 0. So net electric field is 0. That means electric field due to plus 0.2 should be equals to electric field due to 0.8, equal but opposite in direction. Okay, direction we are not considering, we are only considering the magnitude. Magnitude wise they will be equal. So let's put that values. So k q1 by x square. Okay, this is the distance from this charge. K q1 by x square equals to k q2 by 0.15 minus x square. Okay, this is x, means this will be 0.15 minus x. Right? Now what? K cancels. Put the values. You don't need to consider nanocoulomb or microcoulomb because that extension will be cancelled. So 0.2 into 10 to the power of minus 6 by x square equals to 0.8 sorry into 10 to the power of minus 6 by 0.15 minus x whole square. Okay, so 10 to the power of minus 6, 10 to the power of minus 6 cancels. 0.2 gives you 4. Okay, point cancels, then 2 4s are 8. So now do the cross multiplication. Okay, if you are comfortable, you can write it in another step, saying that okay, 2 by x square equals to 8 by 0.15 minus x whole square. Then you can cancel them. Okay, that is also fine. Now do the cross multiplication. 0.15 minus x whole square equals to 4x square or 2x whole square. Now take the square root on both sides. 0.15 minus x equals to 2x, or take it on the other side. 0.15 equals to 2x plus x, that is 3x, or x equals to 0.15 divided by 3, that is 0.05. Okay, now this calculation you can do it using a calculator so that you don't make a mistake in the decimal point. Okay, 0.15 by 3 is not 0.5, it is 0.05. Okay, so x is 0.05 meter from the smallest charge, 0.05 meter from the 0.2 microcoulomb charge. This is the correct way to write the answer. Okay, so if you just leave your answer over here, the invigilator, the examiner will definitely deduct 1 mark. You have to mention 0.05 meter from 0.2 microcoulomb charge. That is the correct way to write the answer to get full marks. Okay, not difficult? Yes, correct. Now next question. Distortion is answering, always answering before me. A conducting sphere of radius 10 centimeter has an unknown charge. If the electric field 20 centimeter from the center of the sphere is 1.5 into 10 to the power of 3 Newton per coulomb and points radially inward, what is the net charge on the sphere? So here we have a sphere. Okay, let me draw a smaller sphere. And we are trying to find the electric field at a distance which is 20 centimeter. Okay, the radius of the sphere is 10 centimeter. It has some unknown charge. Okay, this year 2025 similar question came. Instead of charge, they have given the charge density. So if the charge density is given, okay, surface charge or volume charge, if it is surface charge density for a conductor, you have to multiply surface area. If volume charge density is given, you have to multiply total volume. Mostly conductor will be given. So for a sphere, the volume is 4 pi r square, surface area is volume 4 pi r square, and volume is given by 4/3 pi r cube. So these are the additional formula that you need to know. Okay, don't try to remember all the surface charge density related equations. Only thing you have to consider, what is the total charge. If you can identify the total charge, the problem is very, very simple. Okay, so here this is an unknown charge. We are finding electric field at a distance greater than the radius of the sphere. So that means electric field will be K unknown charge divided by the square of the distance. Inside the shell it is 0, outside the shell it is always K cube by r square. Okay, so now this is mentioned that this is pointing radially inward. Electric field is radially inward. That means this electric field is negative in sign. Radially outward is considered positive, radially inward is considered negative. Okay, and that is basically give you the charge, negative charge. It will give you a charge is negative. That's it. Anyway, do not worry if you identify the charge is negative. If you mention that at the last line after solving it, because the electric field is radially inward, the charge will be negative. That is also accepted. So electric field here given as 1.5 into 10 to the power of 3 equals to K is 9 into 10 to the power of 9 into Q divided by 20 centimeter, 20 into 10 to the power of minus 2 whole square. Okay, now calculate the Q. Q will be minus 1.5 into 10 to the power of 3 into 400 into 10 to the power of minus 4 divided by 9 into 10 to the power of 9. What I have done, I have just cross multiplied. This goes up, this goes down. Okay, just cross multiplication. 4 into 1.5 is 6, so we get minus 6 into 10 to the power of 5 minus 1, 10 divided by 9 into 10 to the power of 9. So you can say minus 60 by 9 into 10 to the power of minus 9. Why I am writing it like this instead of cancelling 1 0? Because it will give me a nanocoulomb charge. Okay, it will give me a nanocoulomb charge. Okay, so 60 by 9 is 20 by 3. 20 by 3 means 6.66. 6.67 nanocoulomb. Okay, 6.67 nanocoulomb is the charge on the sphere. Very easy question. Okay, not 1.5 distortion. Check your answer. It should not be 1.5. Even if you take 10 to the power of minus 8, no, it will be 0.67. 0.67. If you are taking 10 to the power of minus 8, you will get 0.67. Make sure 1.5 into 4 is 6. 1.5 into 4 is 6. Okay, 6 divided by 9. So if you are doing 10 to the power of minus 8, it will be 6 by 9. That is 2/3. Okay, 2/3 means not 1.5. 2/3 is not 1.5. It is 0.67. Okay, it will be 0.67. It is 6 coming in the numerator, 9 is in the division, not 9 by 6. It is 6 by 9. 6 by 9, so 2 by 3 is not 1.5, it is 0.67. Okay? Yes, correct. Correct. Now, let's move on to the next question. Calculate, now we are solving some potential related questions. Calculate the potential at a point P due to a charge of 400 nanocoulomb located 9 centimeter away. Obtain the work done in moving a charge of 2 nanocoulomb from infinity to the point P. does the answer depend on the path along which the charge is moved? Okay, so if the derivation is coming from electric charge and field, which is probable because last year the derivation was asked from electric potential, so might be this year you will get a question in your paper 1. You will get a question from electric charges and field for as a derivation, and a numerical question will come from electric potential, which is 60-40% chance is there. Calculate the potential P due to a charge 400 nanocoulomb 9 centimeter away. So we have a 400 nanocoulomb charge and 9 centimeter away. We are trying to find the potential. Here it is potential. Potential is given by KQ by R. Don't make the mistake where you put an R square for potential. Potential is only one single R. Okay, K is 9 into 10 to the power of 9. The charge is 400. Nanocoulomb means 10 to the power of minus 9 divided by R is 9 centimeter. 9 into 10 to the power of minus 2. So 9 cancels, 10 to the power of 9, 10 to the power of minus 9 cancels, and we get 400 into 10 to the power of plus 2, that is 4 into 10 to the power of plus 4 volt. Okay, unit of potential is volt. Okay, unit of potential is volt, not volt per meter but volt. Now what about the second part? Obtain the work done in moving a charge of 2 nanocoulomb from infinity. So work done, this is part A. Work done is given by Q into V. Calculate it. Let me have some water. I am feeling thirsty. B is 8 into 10 to the power of minus 5. Let's see. So 4 into 10 to the power of 4 into charge is 2 nanocoulomb, 2 into 10 to the power of minus 9. So it will be 8 into 10 to the power of minus 5. Yes, correct. So 8 into 10 to the power of minus 5. What is the unit? What is the unit? Yes, joules. So work done, units will be joules. You can also mention volt into coulomb, that is also fine. Coulomb into volt is also joules, coulomb volt, and here it will be joules. Joules is the unit of work done. So correct answer is 4 into 10 to the power of 4 volt and 8 into 10 to the power of minus 5 joules. And it is independent of path because electric field is conservative, work done is independent of path. So that part also you have to mention, work done is independent of path taken. Sorry, I missed a E over here. Okay, it is independent of the path taken. Now question number 37. Capacitance of a parallel plate capacitor, air capacitor, is 1 nanofarad and the plates are separated by 2 millimeter. Find the area of the each plate of the capacitor. So it's an air capacitor. So C equals to A epsilon naught upon D. C equals to A epsilon naught upon D. So they are asking you to calculate the area. So area will be C into distance divided by epsilon naught. Okay. So now C is given here 1 nanofarad, 10 to the power of minus 9. Distance is given 2 millimeter, 2 into 10 to the power of minus 3 meter, and epsilon naught is 8.854 into 10 to the power of minus 12. Okay, don't make mistake, it is epsilon naught, not 1 by 4 pi epsilon naught. Okay, epsilon naught is 8.854 into 10 to the power of minus 12. Now if you simplify everything, you can calculate the area 10 to the, I believe it will come out to be 2 by 8.854 meter square. Okay, almost 1 by 4.5, that is to approximately 0.25 is 4, 1 by 4 is 0.25, approximately 0.2 meter square. Approximately 0.2 meter square. You can calculate using exact 0.22 meter square. Okay. So approximately 0.2 meter square. So 1 by 4 is 0.25, and here we are getting 4.4. So that will be approximately 0.2. Okay, so it will be 0.226. If you take one more decimal, it will be 0.226 meter square. So 0.22 is also sufficient. Fine. Now next question. This is again one of the common question. Two charges of 10 microcoulomb and 5 microcoulomb are 12 centimeter apart. Find the work done in bringing the charges 2 centimeter closer. So here we have two charges, okay, 10 and 5, both are in microcoulombs. Initially they are at a distance of 12 centimeter. Now if you want to bring them 2 centimeter closer, then the distance will become 10 centimeter. Okay, so because they are now 2 centimeter closer, initially they are at 12 centimeter distance, now they are at 10 centimeter distance. So how to solve this question? To solve this question, you have to calculate the potential energy of the system, potential energy of the initial potential energy and final potential energy. So initial potential energy is given by K, Q1, Q2 by R. Potential energy, not Coulomb's law. Potential energy of two charges are given by is given by K, Q1, Q2 by R. Okay, so initially obviously K is 9 into 10 to the power of 9. Q1 is 10 microcoulomb. And Q2 is 5 microcoulomb. Okay, and R is given here 12 centimeter. 12 centimeter means 12 into 10 to the power of minus 2. You don't need to write in the question, you can show it directly in the question itself. As long as you are doing it properly, this is fine. Now let's solve it. So 9 into 5 by 12. Now let's adjust the 10 to the power of values. 10 to the power of 9 plus 1, 10, minus 12, 10 to the power of minus 2, minus 2, minus 2 cancels. So this is the initial potential energy, 45 by 12, or it will be 3 4s are 12, 15. So 15 by 4 is the initial potential energy, approximately 3.9. Okay, now you can leave it here, you can calculate it, does not matter. So initial potential energy is calculated. Now you have to calculate the final potential energy. Final potential energy is given by UF. UF is given by K, Q1, Q2 divided by, here it was R1, now it will be R2, that is 9 into 10 to the power of 9 into 10 into 10 to the power of minus 6 into 5 into 10 to the power of minus 6 divided by 10 into 10 to the power of minus 2. So this is the final potential energy. Okay, so whenever there is a work done related problem, you have to calculate the final and initial potential energy of the system of charges, then find the difference. Okay, it will be almost similar, 9 into 5 divided by 10. Okay, it was 12 over here. You can directly write it will be 10. Okay, everything 10 to the power values will be cancelled anyway. So it will get 4.5. 4.5 and 15 by 4. 15 by 4, can I calculate? It will be 3.75. Yes, 3.75, and now it is 4.5, and the potential energy will be in units of joules. So change in potential energy is the work done. So work done to bring them to 2 centimeter closer is actually the difference in the potential energy. Difference in potential energy is change in the energy. So we get 4.5 minus 3.75, which will be 0.75 joules. So correct answer is 0.75 joules. Jia is saying how to score 65 in physics. Shankar is saying if I want good in physics, I should go chapter or weightage wise to get good marks. Yes, so first step is to complete your 4 or 5 high weighted chapters. Okay, 4 or 5 high weighted chapters. Now in those high weighted chapter, what you have to do? Do you open the book and study everything? No. So in those high weighted chapter, what you can do, you can prepare the questions that is there in those high weighted chapters. 2 marker, 3 marker, numerical questions, okay, MCQ questions. Practice those. You can use your question bank for reference. And if you only want to study, no sir, I don't have that much time, I don't want to go chapter wise, then what you can do, you can go question wise. Okay, so that approach we are taking, because question wise approach I feel is most appropriate than chapter wise at this stage. Okay, so question wise, solve some questions, numerical questions, solve some MCQ questions, solve 2-3 marker questions, read them, 2-3 marker. Practice some of the derivations. Derivation practice is also very, very important. I know you think that derivation is very easy, I will score marks, but in derivation many students lose marks, 1 or 2 marks, because they are not doing it properly, or while doing it, because they have not practiced it, they make mistakes in the calculation. They make mistakes in the steps. Okay, if the teacher is the teacher who is checking your paper, if he is patient, if he is checking them properly, and because they are checking so many papers, they will identify the mistakes that you are making. You think that even if I make small mistakes in between, teacher will not be checking it, but they will check it. Okay, so don't remain that much confidence. Yes, 0.75 is the correct answer. I think there is one mistake I made. There is a 0. This 0 is not there. Okay, 0.75 joules is the answer. Now next, now 2 very important alternating current based question. A series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad, and resistor of resistance 40 ohm. If the AC source of 200 volt 50 Hz is present in the circuit, find the impedance, also find the resonant frequency of the circuit. Now this chapter, AC chapter, many students ignore because they think, oh, this is too complicated. Actually AC is easy. Why? You only need to remember few formulas, apply those formulas and solve them. You need a small calculator to calculate the values. Otherwise, AC is easy chapter. It is very simple formula. Put the formula, get the result kind of chapter. Okay, so I will show you here. So LCR circuit contains pure inductor, capacitor, and resistor. Okay, find the impedance. How to calculate impedance? This is very important to know. Exact this question will not come, but whatever formulas that I am using will definitely be coming in your final exam. The same similar formulas will be asking. So XL is given by 2 pi F into L. Okay, XL is 2 pi F into L. So what is 2 pi is 3.14, and frequency here is given 50 Hz, and the inductance is given 5 Henry. Okay, so you multiply them, you get 100, 500, 500, 1500, 1500 into 0.1550. So 2 5 is 100, 100 is 314, 314 into 5, 314 into 5, so it will be 1570 ohms. Okay, don't try to calculate like me in your head. You have a small simple calculator, you can use that to calculate the final result. Okay, you can calculate the final result using simple calculator. So that's what I'm saying, that calculator is required to solve this question, and you are very much happy to use calculators, otherwise the problems are simple enough. Capacitance is given by 1 by 2 pi F into C. This is something you need to put little bit more attention, because capacitances are generally given in microfarad, so that microfarad you have to adjust. So this is XC, you have to be little bit careful about. So 2 into 3.14, frequency is 100, sorry, not 100, what I'm doing, frequency is 50, frequency is 50, and capacitance is given here 20 microfarad. Micro means 10 to the power of minus 6, that is in the division, so you have to take that in the top part. So what you get, 10 to the power of 6 divided by 100, 314 into 20, 314 into 20. Okay, so you need to calculate this value. So it will be 10 to the power of 5 by 314. So you can adjust that 100 10 to the power of 3 divided by 6.28. Okay, to calculate XC you definitely need a calculator. Okay, 1000 divided by it will be, I'm not sure the exact value. Anyway, so XC value if you can calculate, please tell me the value. So XC will be 500 by pi. If you are using a calculator, calculate this value 500 by pi and tell me the answer. Okay, someone already calculated the impedance. The tech, yes sir, if I want to good physics, should I chapter I mentioned. Sir, where can I get previous year question papers, toxic yastra? So if you have any books like Jeevit latest edition, they will have all the previous year papers at the end of the book. Okay, I'm not sure if there is a dedicated book of PYQs. Jeevit is one book where you will get the PYQs of the last 10 years. XC is 159.2. Okay, so it will be 159.2. Thank you. So this will be again XC and XL always write the unit, that is ohm. Now what is the impedance? So impedance is very simple, square root of R square plus XL minus XC whole square. If you, while solving it, if you find that XC is greater than XL, don't worry, there is a square sign for a reason. So even if it is smaller minus bigger, it will always be positive. Don't worry about it. Okay, so everything is step by step process. Okay, resistance is 40 square, XL is 1570 and XC is approximately 159 whole square. Okay, now what is the value? If I am not mistaken, it will be, okay, 1410.6. okay, thank you. So impedance will be 1410.6 ohm. Okay, you can use the calculator. As I mentioned, you require a calculator you can do the step-by-step method using a calculator, or you can directly use the calculator. Make sure, because you are not using scientific calculator, step-by-step doing is important. If you are doing step-by-step, that will be much more easier for you to avoid any mistake, and you write it down step-by-step. Teacher will also realize that you have done it properly. Okay, so that is one important part, that you are not allowed to use scientific calculators. Now they ask you, impedance part is done. So this is part A. Okay, next find the impedance, also find the resonant frequency of the circuit. Now resonant frequency you can calculate using simple formula. Resonance frequency is given by 1 by 2 pi square root of L into C, and the unit is in hertz. Okay, unit is in hertz. So again 1 by 2 pi square root of L is 5, C is 20 microfarad. Okay, so 520 is 100. 100 into 10 to the power of minus 6 will be 1 by 2 pi 10 to the power of minus 4 square root, right? 100 10 to the power of minus 6, so you get this as 1 by 2 pi into 10 to the power of minus 2, or 100 divided by 2 pi, or 50 by pi. So it will be 50 by pi. So approximately 15-16 hertz. Okay, so correct answer will be 16 hertz. Okay, yes. Make sure, Rocky, you make a mistake in the 10 to the power of 2 value. It will be 10 to the power of plus 2, not minus 2, because 10 to the power of minus 2 was in division. So when it is going up, it will be plus and it will become 10 square, that is 100. Okay, so don't make that mistake. 10 to the power of minus 2 was in division. When it goes up, it becomes plus and it will become 10 to the power square. So 100 by 2 pi, that is 16 hertz, not 0.5 into 10 to the 0.15 into 10 to the power of minus 2. Okay, your answer is almost correct, only you make a mistake in 10 to the power value. So make sure, so 10 to the power of values you have to be careful about, and the formulas are very straightforward, simple. They will 99% they will give you ask impedance, current, okay, resonance frequency and phase. This is the new thing. Phase we will solve in this question. Phase we will solve in this question. A sinusoidal voltage of RMS value 200 volt and frequency 50 hertz is applied to a series RC circuit. No L is here, only R and C, which is R equals to 3 ohm, C equals to 800 microfarad. Calculate the impedance of the circuit and the current through the circuit. Phase difference between current and voltage. Okay, so even though it is RC circuit, I will explain if it is LC circuit as well, how to solve LCR circuit also, how to solve the phase. So first part is same. Okay, you have to start with XC or XL. Here only C is there, no XL, so XL is 0. So XC will be equals to 1 by 2 pi F into C, or 1 by 2 pi into 100 into 50 into 50 into C is 800 microfarad. Okay, or 10 to the power of 6 divided by 100 pi into 800. Okay, 2 into 50 is 100. So I just want to cancel some of the zeros, that's why I am writing it like that. So 1, 2, 3, 4 zeros will cancel and we get 10 square by 8 pi. Okay, so it will be 100 divided by 8 pi. 8 pi is very close to 25. You can use, as I mentioned, you can use the calculator to calculate the value, but I think it will be very close to 4 ohm. Okay, very close to 4 ohm. Now what is the impedance? Part A, impedance is given by square root of R square plus XC square. Here XL is 0, So you just need to put XL equals to 0 and this will be the formula. Do not add them by like resistances, okay? In AC, resistances are not added like that. You have to use square formula, okay? So here it will be square root of 3 square plus 4 square, which will be approximately 5 ohm. Impedance will be very close to 5 ohm. Now impedance is calculated. The current through the circuit, how to calculate the current? Current through the circuit is given by voltage divided by impedance. Okay, Ohm's law, only instead of resistance we will use impedance. Voltage was given 200 volt and impedance we have calculated 5 ohm, so it will be 40 ampere. So impedance current is calculated. Next, phase difference. Phase difference, how to calculate phase difference? Phase difference is tan inverse, okay, remember this, XL minus XC modulus divided by R. Okay, why I like to use this formula? Because in some cases you will find XL is greater than XC, in some cases you will find XC is greater than XL. For example, for this one there is XL equals to 0, okay. So if you put a modulus sign, the plus or minus does not matter, okay. Only thing is, if XL is greater, current is lagging. If XC is greater, current is leading. That is the difference between XL and XC, who is greater. Otherwise, this is the formula. Now again, as I mentioned, that in many cases you will not be able to find the exact angle. In case you are not, you can leave it in the tan inverse form. Here XL is 0, so XC is 4 by 3, okay, and tan inverse 4 by 3 is approximately 53 degrees. It is a standard angle.
Yes.
Hello students, there was some delay due to some technical issue. So as you can see, I was solving the questions, but I got disconnected in the midway, and then again, hi Shankar, hi Parsu, Sanjay, Blossoming Flora, hello. So I'm extremely sorry, there was a major power outage happened in our studio and entire internet system was down for some time. We tried to restart the live again, but then also it was not working. So after some fixing, we are I am happy to live again. I thought I will not be able to take live till 2 p.m. but thanks for our backend team, they helped me to set it up, and I am able to take the live again from here on. So as you can see, we are solving the last question, and I hope I mentioned that when calculating the phase difference phi, you should remember XL minus XC by R is the formula. If XL is 0 or XC is 0, does not matter, you take the modulus. So when you are taking the modulus, basically that eliminates any negative or positive sign. And tan inverse value, if you are not able to solve tan inverse, for example in this particular case, tan inverse value is obviously well known, that is 4 by 3 is 53 degrees. There are two angles you should remember, 53 degrees and 37 degrees, apart from the standard 0, 30, 45, 60, 90 degree angles. These two angles 37 and 53 are complementary angles. So 53 is 4 by 3 and 37 is 3 by 4. So those are the three angles that you should remember. Other than that, what else is important is that if you are not able to solve the tan inverse using tan table, okay, sine cos tan table will be provided to you, but if you are not sure how to use it, don't write a wrong value, leave your answer over here, you will get full marks. Okay, you will get full marks even if you are not able to solve the tan inverse value. So when solving phase difference, if the tan inverse value is unknown, leave it there only. Okay, don't try to calculate if you are not sure. That is my suggestion. You will get full marks for writing up to, doing up to this much. You will get full marks. Now let's do some derivation. Derive an expression for electric field at a point outside a charged spherical shell using Gauss's law. So now we'll be doing very important Gauss's law. Sir, from wave optics numericals can come in board exam this year. Jayatith Kulkarni, yes, it is possible. 1 in 3, because if you see the model papers, out of 3 model paper, 1 model paper had wave optics numericals. Okay, so there is a 33% chance that there will be a numerical from wave optics, but from my understanding I will put my bet on ray optics rather than wave optics. So there will be a theory 5-mark derivation coming from wave optics and a 5-mark numerical question coming from ray optics. Ray optics is more important in terms of numericals, but there will be a separate all numerical live session video where I'll be solving all different types of numericals, including the numericals I have solved, not the same numericals but similar numericals, but I'll be solving numericals from ray optics, I'll be solving numericals from wave optics as well, 2 or 3 standard numericals from wave optics. So if you practice those 2-3 numericals from wave optics, you will be good to go, because some of the theories from wave optics are deleted. So I don't expect those kind of numericals will be coming. Okay, but there is a possibility, there is a small possibility the numerical will be coming from wave optics. But that's why I suggest 3 chapters. 3 chapters you should not ignore: electric charges and field, electrostatic potential and capacitance, and alternating current. Alternating current is fixed numerical. Okay, the numerical will definitely come from this chapter. Electric charges and field and electric potential and capacitance. Why these 2 chapters? Because these 2 chapters are easy. That's it. Okay, these 2 chapters are easy for numericals. Current electricity, on the other hand, the numericals can be easy or can be very difficult. Both type of numericals might come from electric charges and field chapter. Ray optics, if you are practicing numericals, that should be only as a backup for you. Okay, in case some of the other questions are difficult, then ray optics should be as your backup. It should not be your main option. Main option should be the 3 chapters: electric charges and field, electrostatic potential and capacitance, and alternating current. These should be your 3 major main banking from where you are expecting to solve 2 numericals. One, I always ask students, have at least 1 backup. So ray optics should be your backup. Ray optics or wave optics, from wherever you are practicing, that should be your backup. Even if the question does not come from ray optics, it is coming from wave optics and you are not sure about the answer, you can still skip that because you have already answered the question from other 2 chapters. Current electricity, as I mentioned, it can be easy, it can be very difficult as well. So current electricity should be with a caution. If you are practicing numericals, if you are very good with numericals, you have solved numericals of current electricity, especially the circuit theory related questions, then you should continue. I have done a live in the past about only numericals from current electricity. You can go and check that out. Circuit theory, which is available in our channel, Circuit Theory Live. So there I have discussed specific numericals of current electricity. That is that will be very helpful if you are looking to start, or if you want to understand how to solve numericals from your current electricity chapter. By the way, so let us do some very few derivations. I will just give you the ideas on how to do the derivations and what mistakes you are making. So first of all, in the derivation, if it requires a diagrams, even though it is not mentioned in the question, if diagrams are required, you have to draw the diagram. If you are not drawing the diagram, possibility is there you might get a 0 marks. Actually, according to the board guideline, without diagram you are going to get 0 marks. Generally teachers don't give you 0 marks, but still if you are not drawing the diagram and if your derivation is poor quality, you might still get a 0 mark. Okay, so in this case, derive an expression for electric field at a point outside a spherical shell. Okay, here diagram is compulsory, so let's draw a circle. Use a compass. Okay, draw a small circle. Using the same compass, just increase the radius and draw another circle from the same center. Okay, first circle should be complete, second circle should be dotted. Okay, dotted represents Gaussian surface. So electric field on the outer side. So this is the radius, this is the distance small r. Now electric field inside the shell will be 0. Okay, if they ask you what will be the electric field inside the shell, you just need to mention that there is no charge enclosed, so electric field will be 0. Okay, so charge on this shell, say q. Okay, electric field at distance is r. Charge on the shell is given. Now what is Gauss's law? Gauss's law states that close integral E dot ds equals to charge enclosed divided by epsilon naught. Very simple. Okay, so electric field at this point, say E. Okay, dA, you take a small surface area ds. Okay, then E dot ds close integration is given by q by epsilon naught. Close integration means if you start from here, after completing the entire thing, you have to come back to the same point. Close integration means starting and ending point are same. Okay, and it's a surface integration. Surface integration, you have no idea how to do surface integration, but by the way, for this chapter it will be easy because this is a symmetric surface. Here is a most symmetric surface, and because of the symmetry, electric field is constant due to symmetry. Okay, on this surface, say this surface is S. On the surface S. Okay, so this is the major important thing. You have to show the diagram, you have to mention this is the Gaussian surface. Now if you are not describing in words, you have to describe the diagram. You can write that let us consider a sphere of radius capital R, okay, a spherical shell of radius capital R. Now we want to find the electric field at a distance small r, okay. Let us construct a Gaussian surface of radius smaller, spherical Gaussian surface of radius smaller. That is okay. Otherwise, you have to mention that in the diagram itself. If you mention in the diagram also, that teachers generally consider it. Okay, if you are drawing the diagram properly and mentioning everything in the diagram, that is also fine. So E is constant on the surface due to symmetry. So if it is something is constant, then we can take it outside the integration, and we get integration ds. Okay, now why there is dot product we are not considering? Because the direction of electric field and ds vector, they are also in the same direction. Ds vector and electric field are in the same direction, so their dot product is basically E into ds. Cos 0, cos 0 is 1, so simply E ds equals to q upon epsilon naught. Okay, now close integral ds is the total surface area of the sphere. Total surface area. Now here student make mistakes, they put the surface area of the shell. Surface area of the shell is not there, it is surface area of the dotted line or the surface area of the Gaussian surface. Okay, so it will be 4 pi small r square, not capital R square. So it will be q by epsilon naught, or electric field is given by 1 by 4 pi epsilon naught q upon r square. Okay, so this is the electric field on the outside. So this is the outside, and inside charge enclosed is 0. So charge enclosed 0 means electric field will be 0. Okay, now next, define electrostatic potential due to a point charge and arrive at the expression of electric potential at a point due to a point source charge. Very, very important. Now definition of electrostatic potential is the work done required to bring a unit positive test charge from infinity to a point in electric field. Okay, to bring a unit positive test charge, so unit positive is important, and you are bringing it from infinity to a point on electric field, and that work done is basically called electrostatic potential. Okay, the charge has to be unit positive. Now we are trying to find the potential due to a charge q at a point, say P. At a point, say P. Okay, at a distance small r, point is P. Now how to start? First of all, you have to extend this line. You need to take 2 points A and B, very close. The distance between them is dx, and this point A is located at a distance of x, and B is located another distance small dx, and then you have to extend it till infinity. Okay, you have to extend it till infinity. Now you have to take that, you have to state that let us move a unit positive test charge from infinity, and when it reaches point B, okay, A and B are very close to each other because dx distance is very, very small. Okay, A and B are very close to each other because the distance dx is very, very small. Okay, now the work done to move the test charge, from A to B, you have to calculate. First of all, to calculate work done, what we need to do? Work done, if you recall your first PU, work done is given by force into displacement. Work done was force into displacement. Okay, now here one major problem is that force is not constant. Why? Because force proportional to 1 upon r square, Coulomb's law. So based on that, we can say that as the distance is changing, force is also changing. So you cannot simply apply this equation and calculate the total work done. You have to use method of integration. Integration means taking small portions and adding them together to calculate the total work done. So how to do that? First, what is the force on this unit positive charge when it is at point B? What is the force due to this positive charge? Force due to this positive charge is given by K, capital Q into 1 divided by x square. Okay, the distance is x. So this is the force acting on this charge due to the external field. Now if you want to move this charge by a very small distance, during this small distance the force is almost constant. You have to apply exactly equal to that force but in the opposite direction. So the force is acting on this in this direction. You have to apply a force applied exactly in the opposite direction. So force applied, that is force being applied by you or us, okay, as internal system, so that has to be minus kq by x square. So the internal force and external force has to be opposite. That's why the force that we are applying has to be in the negative sign. Negative sign means it is in the opposite direction. Do not miss the negative sign. This is the applied force. This is the force due to the charge. Force due to the charge, and this is the applied force. Okay, so don't forget to mention these things. Now applied force is calculated. Now if you want to move it by a very small distance where the force is almost constant, then the small work done to move it by a small distance dx is given by applied force into dx. Right, now we can apply our old formula that we have learned in our PU1. The applied force into dx, because during this small displacement force is almost constant. Okay, so dw equals to fa into dx. Now to calculate the total work done, we have to integrate it starting from infinity. Starting point was at infinity and ending point was at our point P, which is as a distance small r. Okay, so it will be fa dx. So this is the main thing. Once you have formulated the integration, everything is easy. But how to formulate the integration, it has to be step by step. If you are skipping directly writing, I have seen students, they are writing directly from here and not explaining what is FA, what is the force, why you are doing it like that. So that if you are not doing it, you will lose marks. Okay, so now integration starting from infinity to r. Okay, what is FA? FA is minus kq by x square into dx. Now k is constant, q is constant, minus sign and all the constant coming out of the integration. So minus integration infinity to r dx by x square. Now this is a very easy integration. So now remember, when you started your PU2 and the teacher came and did this derivation, you are thinking, oh, what is this? So physics is so difficult. But now at this point, when integration is done, you are doing so hard integration nowadays, and you think that, oh, that crazy thing is no longer there, right? So if you feel that same way, please let me know in the chat. Okay, because I have seen students, because it is the second chapter, that time students do not have any proper idea of integration. They are learning integration through physics only, and students struggle with this kind of derivations. Now this should be very easy. So work done to move the charge is basically given by, now you can take this minus sign common, so minus minus becomes plus, you get kq. Now put the upper limit first, 1 upon r. Instead of x, you have to put the upper limit. Minus sign is common, it is outside, minus minus plus now. And next you have to put minus 1 by lower limit, that is 1 upon infinity. Okay. Now 1 upon infinity is 0, so we get work done equals to kq by r. So work done is calculated. Now by definition, this is the electrostatic potential by definition. This is the electrostatic potential, so that means it is kq by r. Now it is time to give a formal look. How to give a formal look? Put the value of k, 1 by 4 pi epsilon naught q upon r. So you give it a bow and tie so that it looks good. Okay, it was like k, now you have to put the value of k, right? Jaitit is saying, sir, instead of doing derivations, can you make us to solve more numericals? No, sir, because many people already practice these derivations many times, or ask, sir, every day derivations or numericals. Jaitit, this year paper Bunny 3 G3 paper will be medium. As usual, there will be not super difficult, and yes, Jaitit, you are correct. Now why I am practicing derivations? Because derivations, even if you have practiced, you make mistakes because you are not writing this, you are starting with this line. Secondly, I will be doing a dedicated 50 numerical question video, okay, live only. Okay, so that's why if I solve all the numericals today, I will not be having enough numerical to solve in that lecture. Okay, so that's why I decided today I will be solving only 10 very important numericals, very standard numericals. So those 10 numericals are already discussed. Now I have decided, okay, let me solve some derivations as well. If you don't want me to do the derivations, and obviously I can ask. If anyone else wants the same, I can add some more numerical questions. But today I do not have any other numericals with me, but definitely I will be doing more numericals in this channel, in this series as well, not today, okay, in our upcoming videos. First of all, on this Sunday 9 AM, mark this on your calendar that I will be solving all 3 model papers, including MCQs, including numericals, including derivations. Maybe I will be not doing derivations, only if this is tricky derivation I will be doing. Otherwise common derivations I will not do. Tricky derivations I will be doing. I will be also doing 2-3 marker questions. I will explain briefly. 2-3 marker numerical questions I will be doing. 5 marker all 3 numericals. There are 12 numericals in those 3 papers. That also I will be solving on live class. Okay, so don't miss out on there. And there will be a dedicated live for numerical questions only. Okay, because I took derivations today because many students have difficulty of writing derivations, and they actually do not draw the diagram, do not understand what they are missing out, why they are not getting full marks in the exam. So that's why our target is to get 70 out of 70, right? So that's why I decided to do some derivations, because derivation practice is also important. Derive the expression for electric field at a point on the equatorial plane of the electric dipole. So, and you are correct, electrostatic potential and capacitance, you are going to get one derivation. Electrostatic potential and capacitance and electric field combined, both chapter, you are going to get one derivation, one numerical. Pakka, okay, no doubt. So electric field on the equatorial plane of a dipole. Asher is saying numericals. Jaitit, numerical I will be doing obviously. Asher, please. Okay. Basavaraj is saying numericals. Asher is also saying numericals. Venom is saying I don't understand dipole. Let me explain to at least this one. So derive the expression for electric field at the point on equatorial plane of a dipole. So first of all, what is a dipole? Dipole is one positive charge, one negative charge separated by a small distance, say 2L. That is called dipole. Now in physics it can be little tricky. What is dipole, sir? I don't understand. If you go to your chemistry class, okay, the chemistry teacher will say there is a hydrogen, there is a chlorine, okay, and chlorine has 7 electrons, hydrogen has only 1 electron, okay, hydrogen will try to get 2 electrons in its outer shell, chlorine will try to get 8 electrons in its outer shell. So what they will do, hydrogen will give its 1 electron to chlorine and chlorine will give 1 of its electron to the hydrogen, and they will share this bond to make them a covalent bond. But after giving the electrons, chlorine will say, see, hydrogen, you are very weak, I am stronger, I have higher electron affinity. So what I will be doing, even though I am giving you the electron, okay, I will keep both of yours and my electrons near me. Okay, so basically even though hydrogen is giving its electron, chlorine is giving its electron, so what chlorine will say that because I have higher electron affinity, I will keep the electron pair closer to me. You can enjoy, you can relax. Okay, now what happens in this process is that chlorine gains a very small negative charge, chlorine gains a very small negative charge, and hydrogen gains a very small positive charge. Okay, and this is because they are forming a covalent bond, that bond length is very small. So this is a real example of a dipole. Okay, this is a real example of dipole. So dipole exists in nature mostly through covalent bonds and where the electron pair is not perfectly oriented. Okay, so there are some covalent bonds where both electrons are located at the center. In that case dipole moment is 0, but if the covalent bond shifts towards the higher electron affinity molecule, higher electron affinity atoms, then there is a dipole formation happens. Okay, and this is basically the starting point of dipole. Water is also, you have learned in chemistry, water is a polar solvent. What is the meaning of polar solvent? So if you see that oxygen is there, hydrogen is there, okay, 2 hydrogens are there, and as I mentioned that electron pairs will now be taken away by the oxygen. Hydrogen is always lonely. Okay, now you will have a net dipole moment from negative to positive charge in this direction. So this is the basic fundamental of dipole. Now dipole, that is in chemistry, but in physics we are not interested how they behave in the presence of other chemicals. Okay, but what we are interested in, electric field due to a dipole. Okay, so electric field due to a dipole is basically, suppose this is negative charge, this is positive charge, and when they are separated by a small distance of 2L, that means this distance is L, this distance is also L, then this is called a dipole, and we can find the electric field on its axis, which in my opinion is slightly easier, and electric field on the equatorial plane. Equatorial plane can be tricky if you are not sure. Okay, so remember that. Okay, let me change the polarity. Let me take, this is positive, this is negative, that will be easier. So this is positive, this is negative, this is slightly easier to solve, at least for equatorial plane case. Now you don't need to consider them as dipole. Initially you can consider them as single charges. You can consider them as single charges. So this is a plus Q charge. Because of plus Q charge, the electric field will be pointing outside. So this is plus charge, and electric field due to the negative charge, what will be the direction? It will be towards it will be towards negative charge, it will be towards the negative charge, right? So this is how the dipole looks like. So this is positive, this is negative, but if you understand slight geometry, that this is a triangle and this is the bisector which is separating the base into two halves, that means it will be an isosceles triangle. So these two both distances will be same. Okay, both distances will be same, say r dash, and this distance is small r. Okay, now you can apply Pythagoras theorem to calculate r dash. R dash is actually r square plus l square, right? This is the distance. So this is a right angle triangle. So r square plus l square, square root is the value of r dash. Okay, now if this angle is theta, obviously it is not 60 degree because it's not equilateral triangle, it is only isosceles triangle. So if this angle is theta, this angle will also be theta. Now if you take the x component of both these electric fields, so E plus and E minus, okay, then only x component will be there. X component, this angle will be theta, this angle will also be theta. This is theta by virtue of similar angle, and this angle is theta by the virtue of alternate angle. Okay, now so both angle is theta. Now y components will cancel each other, so only x component will remain. Now first of all, what is the value of E positive? E positive and E negative both will have same value magnitude wise, because charge magnitudes are same, distances are also same, and that field, say, given by a constant E. What is E? For a point charge, K Q by R square, here R dash square. Okay, so this is the electric field due to the both charges, same value. Directions are wrong, but if you consider the directions, okay, y component for both the electric fields, you can resolve this electric field into two components. Okay, one is along x direction, one is along y direction. Same for this as well, one is along x direction, one is along y direction. So y directions will be opposite direction, so they will cancel. X directions will be in the same direction, so they will add up. So the net electric field is given by E cos theta plus E cos theta. This is the angle theta, so adjacent angle, so E cos theta for this. This is the angle theta, so E cos theta for this as well. So both gets added and you get 2E cos theta. Now everything is done. Now you just need to simplify this. How to simplify? So net electric field is given by 2 into KQ by R dash square. R dash square is R square plus L square. And what is cos theta? If you see this, cos theta is base by hypotenuse. So it will be L divided by R dash or L divided by square root of R square plus L square. Okay, now put that here. 2 into KQ, here was a cos theta, into L divided by R square plus L square into square root of R square plus L square. So it will be R square plus L square to the power 3 by 2. Okay, it will be R square plus L square to the power 3 by 2. Now slight rearrangement, 2QL divided by R square plus L square to the power 3 by 2. Now this term 2QL is called dipole moment. This term 2QL is called dipole moment of the dipole. So it will be K into P divided by, now for a point R very greater than L. Okay, so this distance is very greater than compared to the distance of the dipole. We can say this will be simply R square to the power 3 by 2, or it will be 1 by 4 pi epsilon naught P upon R cube. Now, so one more step is there. If you don't, if you ignore that step, you will be losing marks. What is that step? That is, dipole moment is from negative to positive. It's a vector quantity. Dipole moment is from negative to positive, and the net electric field, okay, is from positive to negative. So net electric field and dipole moment, they are in the opposite direction. So vectorially, net electric field will be equals to minus 1 by 4 pi epsilon naught p vector by r cube. So there has to be a negative sign involved over here. If you are not showing the negative sign, marks will be deducted. Because these are the small things that you might ignore because thinking that, okay, I don't need to show it, you need to show it. Okay, vectorially E and P are in the opposite direction, so there will be a negative sign coming over here. Good morning, Ganesh. Hello, Rakshit. So now this derivation is done. Now let's move on to the question number 44. Obtain an expression for potential energy of an electric dipole placed in an uniform electric field. Define energy density of a charged capacitor. How the energy density is related to electric field present between the plates of a capacitor. Okay, first portion, expression for potential energy of a dipole placed in an uniform electric field. This is also very important derivation. Okay, we have a electric field and we have a dipole placed here. This is very tricky. This derivation is very tricky, by the way. This derivation can be tricky. Many students ignore this derivation. You do not ignore this. Suppose we have a positive charge, negative charge. The charge is experiencing a torque. The angle is theta. So what is the torque acting on this dipole? Torque acting on this is P into E sin theta. P into E sin theta is the torque acting on it. You don't need to show this expression of torque unless it is asked. Let's show the torque acting on it. That is a separate derivation. So that derivation you can do if that derivation is asked. Otherwise, in this case, torque acting on it is P sin theta. You don't need to show the expression derivation for this. You can start from this point. Okay. So torque is given. Now what? You have to calculate the potential energy. Torque is equivalent of force in rotational motion. So work done is potential energy, and that is force into displacement. In this case, force is obviously not there, so it will be torque into angular displacement theta. Now torque is not constant, it varies with theta. So what we have to do, we have to calculate the small work done dW for a small displacement d theta. Okay, torque into theta is the work done in rotational motion. Here it is d theta because torque is not constant. Torque is varying with theta. So let's put that value Pe sin theta d theta. Now what is the total work done? Total work done again is integration of Pe sin theta d theta, and here the limit is very important. It's a definite integration. Limit starting from angle pi by 2 to an angle theta. Okay, so initially it was like this, and you are rotating at some angle from pi by 2 to angle theta. This should be the limit of the integration. Now let's do the integration. You get Pe constant, and sin theta d theta is minus cos theta, and limit is pi by 2 to theta. So now put the upper limit first. Minus cos theta, minus plus cos pi by 2. Cos pi by 2 is 0, so we get minus Pe cos theta. Okay, so this is the work done, and work done is equals to the potential of dipole. So work done is equals to potential or potential energy stored in the dipole. So potential energy of the dipole is given by minus Pe cos theta. Okay, When it is exactly at the equatorial plane, potential energy would be 0. Now, second part, define energy density of a charge capacitor. Energy density of a charge capacitor is defined as total energy stored in the capacitor divided by the volume of the capacitor. Okay, so this is the energy density of the capacitor. This is the definition. You need to write it in terms of words as well. Now, how it is related to the electric field? So, potential energy density is given by half epsilon naught E square. This derivation is not part of the syllabus, but this formula is. So, energy density and potential energy stored in a capacitor is related with this formula, half epsilon naught E square. So, if this question is coming, this derivation will have 3 marks. Okay, the definition, this one will have 1 mark, this one will have 1 mark. Okay. Now, derive an expression for effective EMF and effective internal resistance of two cells of different EMFs and internal resistance connected in series. Okay. Now, how to do that? Easy. Here we have cells say epsilon 1, R1, epsilon 2, R2, epsilon 3, R3. They are connected in series. Okay, and everything is connected through an. Okay, here one thing, they are asking only 2 cells, so we will not draw the third cell. We will not draw the third cell because 2 cells is mentioned. Okay. So this is the external resistance R. Now, if you find the equivalent EMF, that means equivalent EMF means entire system can be replaced by only one cell and one internal resistance. So this is epsilon equivalent and R equivalent, and this is capital R. Now, what are the conditions that we can say this is the equivalent circuit? If the current in the circuit remains same, then we say this is an equivalent circuit. Okay, current through the resistor should be the same value. Now, we will check with Kirchhoff's voltage law what is the current through each and every component. Current should be same because they are connected in series. So in series combination, current should be same. Same current means each of them will same voltage. So what is the voltage drop across the internal resistances? I into R1 plus I into R2, and voltage drop across the external resistance is I into R, and that should be equals to epsilon 1 plus epsilon 2, applying Kirchhoff's voltage law. Okay. Now from this, what you can do, you can calculate I into R equals to epsilon 1 plus epsilon 2 minus I into R1 plus R2. This is the first step. Okay. Now next we will use Kirchhoff's laws again in the equivalent circuit. From equivalent circuit, we can write I R equivalent plus I into R equals to epsilon equivalent. Okay, or I into R equals to epsilon equivalent minus I into R equivalent. Okay, so now if you compare equation 1 and equation 2, we can see that this is all terms related to epsilon, so that means it should be equals to this. Okay, so epsilon equivalent must be equals to epsilon 1 plus epsilon 2, and minus I into R1 plus R2 was there, and minus I into R equivalent was there. So R equivalent must be equals to R1 plus R2. Okay, so this is the comparison. This should be the answer. Very easy, simple derivation. Diagram is compulsory. Applying KVL is also you have to mention. Now, arrive at the balanced condition of Wheatstone bridge using Kirchhoff's rules. Very common question. So here we have, you have to draw the diagrams P, Q, R, S. Now I am going to, as usual, I am going to do the shortcut method for this derivation. So galvanometer current say is Ig. Now what is the condition for balance? Condition for balanced Wheatstone bridge is Ig equals to 0. Okay, so condition for balanced Wheatstone bridge is Ig equals to 0. That means what we can say, I1, therefore I1, so if you see that I1 is in this direction, Ig is in this direction, I3 is in this direction, so I1 equals to I3 plus Ig equals to I3. This is 0, right? If you apply Kirchhoff's current law at junction B, if you apply Kirchhoff's current law at junction B, you will see that I1 is going in this direction, I3 is going out, Ig is also coming in. So all incoming current should be equals to outgoing current. Okay, so here it will be minus, sorry, here it will be minus. So I3 minus Ig, and Ig is 0, and as Ig is 0, that means the I1 equals to will be equals to I3. Similarly, there is some issue, sorry. Similarly, I2 will be equals to I4. Okay, I2 should be equals to I4. Now, this is the first stage. Second stage, you have to apply Kirchhoff's voltage laws. Kirchhoff's voltage law you have to apply on this loop and on this loop. So this is one loop, this is second loop. So A, B, D, A. Applying KVL on A, B, D, A. So this is a loop. Starting point and ending point are same, that's why it is called a loop. So we will start with A. A to B, current is I1, resistance is P, so P I1. Okay, and from B to D there is no current, Ig is there, G is there, so plus Ig into G plus D to A, it is R into I2. And there is no battery connected in this junction, so it should be equals to 0. Now Ig is 0, so we can say Pi1, no, one more mistake I made, here it will be minus, because while going from D to A, we are going in the reverse direction of current. So the current is going in this direction, but to complete the loop we have to go in this direction, and that is why it will be minus. So minus R into I2, or P equals to 0. P upon R equals to I2 by I1. Okay, P upon R equals to I2 by I1. So similarly, now you don't need to do anything, you just need to write similarly from loop BDCB, okay, we can write Q by S equals to I4 by I3. Okay, now I4 and I3 value, I3 is equals to I1 and I4 equals to I2, so I2 by I1. Okay, so this is equation number 1, this is equation number 2. So comparing 1 and 2, we can write P by R equals to Q by S, or P by Q equals to R by S. This is the condition for balanced Wheatstone bridge. Easy, simple, okay, easy peasy lemon squeezy. I am Aisha, please कोई reply दो, total 70 के लिए enough है. So this is not enough for 70 out of 70, but it is the start. If you practice all the numericals, all the questions that I am doing, you should be able to at least score 40 marks. Okay, I have done MCQs, I have done numerical questions, I have done the derivations, I am doing the derivations as well. So 40 marks will be covered in this today's lecture. Obviously 70 out of 70 you cannot say 1 hour or 2 hour videos will not be enough for 70 marks. We are also doing long videos of 1 marker, 2, 3 marker, 5 marker derivations, 5 marker numerical I will be taking live. Do join on those sessions and check all of them. Then 70 out of 70 will be pakka. Okay, Aisha. Okay, derive the expression for magnetic field at a point on the axis of a circular loop. Very important derivation. Okay, so magnetic field on the axis of a on a current carrying loop. So here this is the radius r. You are trying to find magnetic field at this point, say P. The distance from the center is x. The slanted distance is r. Okay, let us take a small portion of current carrying loop of I. Now magnetic field due to this will be, this angle is say phi, the magnetic field will be in this direction and the same angle phi will be there, and you need to take the bx component. So this is the diagram you have to remember by heart. Okay, the other angle is there which is theta is 90 degrees here, theta is 90 degrees. Now we will start with Biot-Savart's law. Okay, Biot-Savart's law says that the magnetic field small dB is given by I dl sine theta by r square 1 by 4 pi mu naught. Okay, so this is the Biot-Savart's law. Now here sine theta is 90, sine 90 is 1, so sine theta becomes 1. Okay, so you can simply say 1 by 4 pi, mu naught by 4 pi I dl upon r square. Okay, here r is this distance. What is r? R is square root of capital R square plus x square. Okay, this is the right angle triangle. So r square plus x square is equals to small r. So dB we have calculated. Now what is dBx? dBx is dB cos phi. Okay, cos phi, cos and component of this angle phi. Okay, so now put the values. Mu naught by 4 pi I dl by r square. Cos phi is same as this angle, so it is base divided by hypotenuse. Base is r, so cos phi is r divided by square root of r square plus x square. Now remember, do not point this angle as theta. Theta is a different angle, that is the Biot-Savart's law. This is phi, phi is different. Okay, phi is different. Theta is 90 degrees, but phi is not. It will be r square plus l square, that is okay, that is r by capital R. Okay, so let me write it like this only. Later on we will put the value. Okay, it is r by small r. So now we get mu naught by 4 pi I into r divided by r cube into dl. Now dl is this portion, and if you see that capital R, x, so that is small r, everything is constant except this dl. So this dl is basically changing along this curve. Okay, so the total magnetic field on this direction will be given by integration of mu naught by 4 pi IR by R cube dl. Now everything here is constant, only dl is changing. So what you can say is, this is basically integration of this is not correct. This is constant, so every constant will be out of the integration, only dl will be there. Okay, now dl of this entire closed circle will be circumference of the circle, so that will be given by mu naught by 4 pi IR by R cube into 2 pi capital R. Okay, so this is the capital R circle, radius capital R, circumference is 2 pi R, so 4 pi 2 pi cancels, and we get the net magnetic field Bx equals to mu naught by 2 IR square divided by R square plus X square to the power 3 by 2. So R cube means R square plus X square whole cube, that is R square plus X square to the power 3 by 2. This is the expression for magnetic field at the axis of a circular coil. At the center, if they ask you the same question, they ask you magnetic field at the center of the coil, you need to put x equals to 0. Now let's move on. Find the force per unit length between two parallel current carrying wires. So here we have two parallel current carrying wires. Okay, this is say I1, this is say I2. The distance between the wire is say D. How to find the force between a parallel current carrying wire? So let us consider a small portion of this, both of the wire as length L. Okay, now the magnetic field due to a current carrying wire at a distance, so magnetic field due to the first wire at the location of the second wire. Okay, so magnetic field at the location of the due to the first wire at the location of second wire. Okay, say B12. So B12 will be given by mu naught by 2 pi mu naught by 2 pi I upon distance. Okay, so mu naught by I, and the magnetic field due to the second wire at the location of first wire, so that will be 21 B21, that will be given by mu naught by 2 pi I2 by D. So these are the formulas. Magnetic field due to a current carrying wire. So magnetic field due to a current carrying wire, individually you have to calculate for both cases. Now what is the force acting? Now due to this magnetic field, there will be a force acting on this second wire. So force acting on this second wire due to first wire, that is F21, is given by B. I think the names should be opposite. It will be magnetic field on first wire due to second wire. Magnetic field, this will be 2-1, this will be 1-2. This will be 2-1, this will be 1-2. Okay, so magnetic force acting on the second wire due to first wire is magnetic field due to first wire into current on the second wire into the length that we are considering. Okay, this length BIL sin theta. Here sin theta is 90 degrees, so the direction and current are 90 degrees, so it is simply BIL. Now let's put that value, mu naught by 2 pi, okay, I1 I2 upon D into L. And magnetic force acting on the first wire due to second wire is B12 I1 into L. So that will be again the same value, mu naught 2 pi I1 I2 by D into L. Okay, both will be same value because magnetic field is symmetrical, so force will also be symmetrical. So we can say that F21 equals to minus F12. Why minus? Because whatever will be the direction of the first wire, the force due to the second wire will be the opposite direction. Newton's third law of motion. So these two forces will be equal but in opposite direction. Say that force is given by small f, capital F, then capital F is given by mu naught by 2 pi I1 I2 by d into L. Now this is not the end. You have to calculate force per unit length. Force per unit length is force divided by L, that is equals to mu naught by 2 pi I1 I2 upon d. This is force per unit length. Now from here they ask you, hence define 1 ampere. So what is 1 ampere? 1 ampere is if I1 equals to I2 equals to 1 ampere, d equals to 1 meter, then force per unit length will be mu naught by 2 pi or 2 into 10 to the power of minus 7 Newton. Okay, mu naught is 4 pi into 10 to the power of minus 7, so if you put it, you will get 2 into 10 to the minus 7. So hence 1 ampere is defined when 1 ampere current is being passed through two wires kept at 1 meter apart. The force acting between them will be 2 into 10 to the power of minus 7. That is the definition of 1 ampere. Okay. Now, full wave, half wave rectifier and full wave rectifier, both are important. What is half wave rectifier? Explain the working of a half wave rectifier using neat circuit diagram. Half wave rectifier is an electronic circuit that converts alternating current to direct current by allowing current to flow only during one half cycle of the AC input signal, and the other half cycle is blocked, so only half of the AC waveform is used. So this is very, very important to understand half wave rectifier. If it is said only rectifier, then you have to mention the rectifier is a device which converts AC to DC. That's it. This is a circuit diagram for a half wave rectifier. Positive half cycle of AC. During the positive half cycle of the AC input, the P side of the diode is positive with respect to the N side. The diode becomes forward biased and conducts current. Current flows through the resistor in one direction and the voltage across the load is positive. During the negative half cycle of the AC input, P side of the diode becomes negative with respect to the N side. The diode reverse biased and does not conduct. No current flows through the load resistor RL and the output voltage is 0 during this half cycle. Okay, so this is the input output diagram. Next is what is a rectifier. Explain the working of a full wave rectifier. Okay, a rectifier is an electronic device that converts an alternating current into direct current. Okay. Positive half cycle, during the positive half cycle of the AC input voltage, the upper half of the so in full wave we have two diodes, in half wave we have only one diode. Remember this, full wave two diodes, half wave only one diode. And major thing is the output voltage is taken across this resistance. It is connected through this central point. The diagram you also have to practice for half wave and full wave. Okay. So for the first half, this diode is positive, diode D1 is positive and or forward biased and conducts, allowing current to flow through the load resistance RL, and diode 2 is reverse biased and does not conduct. Okay, so when this is positive, this is negative. Okay, diode D1 conducts and the current is flowing through RL. Now in the second half, what happens is that during the negative half cycle of the AC input voltage, the lower half of the transformer secondary winding becomes positive. Diode D2 becomes forward biased and conducts, while diode D1 is reverse biased and does not conduct. Current again flows through the load resistor RL in the same direction as during the positive half cycle. So this is the diagram for the negative half cycle and positive half cycle. The diagram has to be shown circuit as well as this output input output conversion. Okay, so for positive for a half wave rectifier, only positive is there and a central part is missing. For full wave rectifier, complete wave is there. Okay, now these are the most common and important derivations. how many marks you can score? Up to 40 marks from this lecture alone. Okay, PDF I will share in our WhatsApp channel. So if you have not joined WhatsApp channel, definitely the link is in the description. So join the WhatsApp channel. The PDF will be uploaded within 1 hour and it will be shared to you as well. Okay, so this is 40 up to 40 marks you can score from this lecture alone, and I will be doing more 2-3 marker videos, all 5 mark derivation videos. I will also be discussing all 3 of your model papers, and also I will be discussing all numericals, all chapter numerics, all important chapter numericals in another live video. Okay, so don't miss out on that. I will be back with 2-3 marker video in another 1 or 2 days. Till then, bye.